Good morning and welcome to the final event of the ENSEMBLE project. ENSEMBLE, short for Enabling Safe Multi-Brand Platooning for Europe, which is exactly what we'll be talking about today, here live from Auto World in Brussels. After 4 years of researching and testing, we're really proud that we can present some of the outcomes to you today. We'll be looking into what the results were of the real-life testing, what was the impact of platooning on road users and traffic flow, is there a business case, and why even consider truck platooning for Europe? Those are the questions that we'll be answering to you today. And you can also see the program underneath the stream in your screen. So stay tuned. I know there's a few hundreds of you out there, and we would have loved to have you all in here with us to celebrate this milestone. But to be on the safe side, we decided to go with this live stream. But I do hope that you feel part of this event and that you share your thoughts and your questions with us through the box that's actually in your screen. And we'll try to answer them as much as possible during the live stream, but we'll definitely get back to you afterwards. So thanks for joining at this live event for the ENSEMBLE project. And to do the official opening, we have here with us Mr. Joost van Tomme, who is the CEO of Ertigo ITS Europe, and he'll give you the official opening and welcome. Joost.
Thank you. Good morning, good noon, good afternoon, good evening, and good night. First of all, a warm welcome to all of you here in the room in Auto World, a fantastic place with trucks, cars, buses, vans, but also you in your office, in your virtual office, wherever you are. Thank you for joining us. This is the day. This is the final day of Ensemble. Ensemble means together in French, and it is actually something we did together. We were exploring two things together. We were exploring how trucks can enable other trucks in one convoy through connectivity, so they talk to each other, these trucks, in a common language and common data exchange. But secondly, they don't only talk to each other, they do it in an automated way. So they run on the street automatically, meaning actually in the second truck you shouldn't actually have a driver. Okay, that's extreme, but that will be the future. So we tested this. And I warmly thank, first of all, the Flemish government representatives, or the Minister Lydia Peters, who is here through a representative to support this. Secondly, I'd like to thank the European Commission. We have numerous interactions with DG RTD on Horizon 2020 projects and Digital Europe for the connectivity part. Numerous interactions with DG Move, with DG Grow. You know that DG Grow is working on an automated driving regulation which will enable platooning, which will also define and regulate V2V communication amongst trucks. What kind of data exchange do we need? So all these great people are here. Very nice to see them also live on the stand. And obviously a warm welcome to the European associations who have been instrumental and have been pivotal to work on this, with ASEA, with CLEPA, IRU, and all many others. I'm sure I'm forgetting a lot of them. So Ertigo ITS Europe, together with TNO, is extremely happy to finalize this event after 4 or 5 years together. I still remember day one with the Dutch ministry. Actually, the Dutch presidency of the European Union was in 2016, when we kicked off a European truck platooning challenge. From 5 countries, trucks were heading to Rotterdam to see how this will go. And it actually worked. It is amazing. And now we have this final event with all the, I would say, all the concrete results of this European-enabled research funding projects. You will hear about this, all of this today. And again, very happy to be with you. We are ensemble, we are together. Thank you very much and enjoy your day. Thank you.
Thank you, Mr. van Tomme, for this opening and introduction. There's one question that's on my mind, and that is, what is the link between Ertigo and Ensemble, or the truck platooning that it studied?
That's a good question. Well, it's very easy. You know, Ertigo is 30 years now. We are a public-private partnership, meaning we've been established or powered by the European Commission 30 years ago. To do what? To bring the public and the private entities together and to showcase that intelligent transportation systems work. So we are providing solutions, innovation, and day-to-day projects for We call it ITS in our jargon. It's about connectivity and automation. It's about urban mobility, about clean mobility, and obviously about transport and logistics. And this is something about logistics. It's about bringing the goods from the warehouse and actually where they have been produced to the final mile, the last mile. And that's being done thanks to our truck drivers and the truck companies and the whole ecosystem which we have in Urtico. Please.
Thank you so much. Sounds like that is in the middle of the sweet spot almost. Thanks for your opening.
You're welcome.
And now we'll go to a short introductory movie that will give you a first flavor of what Ensemble has been all about, and you also hear from some of the participants in the project.
Multi-brand platooning, a reality in Europe. For the first time in the mobility sector, trucks of 7 European brands are platooned together in real-life traffic conditions. This is the result of the EU co-funded project ENSEMBLE. Started in June 2018, ENSEMBLE is a 4-year collaborative effort aiming to ensure higher traffic safety on European roads. Truck platooning is the linking of 2 or more trucks in convoy, using wireless connectivity technology and automated driving support systems to support the drivers. ENSEMBLE brought together the major European truck manufacturers and partners to implement their platooning systems and to test in real-world traffic conditions. On the 23rd of September, 7 trucks of leading European brands drove together during 3 hours. The trucks platooned around the Barcelona region through various traffic conditions: busy traffic, rain, tunnels, and even traffic jams. The basis of this achievement is the specifically developed V2V, vehicle-to-vehicle communication protocol. It supports the correct behaviour and reaction of each of the trucks in the platoon for every envisioned traffic use case.
So the main challenge in this project was to develop an inter-brand V2X protocol, so wireless protocol, which allows to communicate between different brands. And I think this is the main success of the project, that we achieved it.
The most exciting part is the collaboration with all of the partners throughout all the meetings, workshops, and of course the demonstration, because we can all learn a lot from each other and strengthen ourselves through these collaborations and end up with a better end result.
So as OEM, we participated to the main work packages, so starting from the definition of platooning, so levels, how the maneuvers should be, how the platoon, the convoy should look like, and then to the implementation and to test.
So Scania's role in the Ensemble project is to develop a V2X and platooning platform to be able to platoon with all other brands here at Ensemble.
The output is a common solution, ready for further standardization, using secure wireless communication to create a safe interaction within the platoon and with other road users. Truck platooning technology is a significant step forward to fully connected automated driving. It supports improvements in traffic safety, fuel economy, and improvement of logistic efficiency.
Us in the Volvo Group, health and safety is our core values, and today we have been, in this project now, we have been making a huge leap forward when it comes to bringing the vehicle-to-vehicle systems towards their deployment in the truck world in Europe.
Reducing the environmental impact of transport and increasing safety up to close to 0 fatalities by 2050 are some of the pressing current challenges across the EU and globally. Multi-brand platooning is a significant step forward to fully connected automated driving. This will increase transport efficiency, lower air pollution and noise, and will enhance traffic safety by reducing accidents and health impact. ENSEMBLE contributes to the standardization of interoperability between trucks, speeds up actual market pickup across Europe, and enables harmonization of legal frameworks in the member states. ENSEMBLE, together a reality.
I think this movie gave us a great glimpse into what has been happening. Pretty impressive images, actually, of all those trucks on the open roads driving in platoon. And I'm really happy that we have here with us Marieke Hoedemaker. She has been the project coordinator for the Ensemble project and is a senior project manager at TNO. And she will give us even more insight into what Ensemble has been all about. Marieke.
Thank you. Yes, for the coordinator, it's a big honor, but also a challenge to try in 10 minutes to give this overview of a project of almost 4 years. But I'll try to do my best to give you a first glimpse, and then we'll have the rest of the day for much more insights in the great project. So let's start this with a question. Why multi-brand platooning? As you can see here in the slide, we have a lot of pictures of years before us where cars we already tried to develop and support and automate the driving tasks, also specifically for trucks in the lower part. Ending in 2016 with what you might know as the European Truck Platooning Challenge, where platoons of trucks drove through Europe to end up in Rotterdam in the Netherlands. So the next step, the next logical step to make truck platooning more feasible and more deployable for real-world logistic applications is that you want to go from monobrand, because in the years before trucks were able to platoon, but they did this only with their own brands, to make the step towards multi-brand platooning. So different brands could form a platoon together. And that's actually what the challenge of and the objective of the Ensemble project was, doing this together with the other truck brands. Some facts and figures about the project. So it is an innovation action supported and funded by the European Commission. It was supposed to be a 3-year project, but due to all kinds of COVID stuff that you might know, we ended up doing it in almost 4 years. But still, we made it to a good end. We received quite some funding, and we did this together with 19 other partners. TNO as a coordinator, but we had on board in the project all the European truck platooning manufacturers. We had some suppliers, but also the representative of all the European automotive suppliers. We had Ertico, and there were some knowledge partners in there as well, including actually TNO. So the objectives of the project is just one, to pave the way towards the adoption of this multi-brand platooning in Europe. And we did this by working and aligning on the standardization of the multi-brand specifications. We implemented that together in all of those different brands that were on board in the project. And we demonstrated it after implementing in the real world. And then in parallel, we looked at different impacts. What could multi-brand platooning bring when we implement it into the real traffic after the project? And yes, it was a big success. You can see we have here 3 pictures, but in the movie before you've seen some live images of what we did in Spain, where we really demonstrated all those platoonable trucks in one platoon of the 7 brands together in the real traffic. So it really worked under different traffic conditions, even with toll gates, other traffic cutting in. And at the same time, we worked on the specifications for a more autonomous platooning function, which I will come back soon in my presentation a bit to explain you about that. So this is the idea. Ensemble actually discriminated 2 different functions. A support function, the platooning support function, and the platooning autonomous function. And you can see here the main differences of the 2 functions that we developed. The first one, the support function, we actually implemented, and the autonomous function, we provided all the specifications so it can be taken up after the project. The main difference here is actually the legal responsibility. So for the platooning support function, the driver is responsible for his driving task. Also, the drivers of all the trucks in the platoon. He is supported, of course, by longitudinal support in a platooning support function. But the time gaps are relatively large, you can say, because the driver still needs, in case it's necessary, to be able to react and give the reaction time to make it a safe drive and bring it to a safe stop if necessary. At the same time, the platooning support function is ready for a quick deployment on the road because it fits into the current regulatory framework. We described how the function should work, and because we had to do it and implement it. And for the platooning autonomous function, we described what the function should do. So that's more open to see how it's really going to be implemented. But as you can see also in the table, the time gaps for the autonomous function, where there is no driver in the following trucks, there is only a driver in the lead truck, or there is a driver that is not attentive at least, maybe he can go to sleep, in the following trucks. And that makes it possible also to bring the time gap between the trucks to a shorter distance, because there's no driver that needs his or her reaction time to be able to react. Both functions actually are expected to improve traffic safety, traffic flow, but the autonomous function on top of that also is expected to improve the driver productivity and more improved fuel efficiency because of the shorter time gaps. So, how did we do this? These were the specifications. We started with, of course, implementing it in the trucks. Before we did that, we made the reference implementation, which is a brand neutral implementation that could first be tested in a hardware in the loop simulator. And then after that, the OEMs could take this reference implementation, the brand neutral one, to either equip their own trucks with that reference implementation or to use that as an example and build their own implementation of the support function in their trucks. They tested it with their own brands first, then we tried to come together with two brands, seeing if it works with two, and after that with three, after that with four, and then culminating in the last tests last September with all 7 brands tested and working on the roads. The starting point of the platooning support function is the current available state-of-the-art for ACC and AEBS. We did this, as I said, to be able to have it introduced into the traffic without any legal obstacles there. So ACC and AEBS are already there, but to make it very clear, we added on top of that, very important, the V2V communication, the vehicle-to-vehicle communication, which adds to the ACC much faster reactions between the trucks in the platoon, which already brings some improved string stability for normal driving, so no harsh braking there, just automatic distance keeping and speed control. And when it is necessary, when emergency braking is necessary, we use the state-of-the-art AEBS, but added again the vehicle-to-vehicle communication, which brings the almost instant warnings to the drivers if needed before the AEBS is braking by itself. As a comparison, normal AEBS works with the radar, which needs about half a second to start with to detect the vehicle in front braking and then take an action on that. So is this the same as cooperative ITS or cooperative ACC, the adding of V2V? No, it's actually not exactly the same. You can see here in the picture the main differences. With cooperative ITS, the vehicles share their behavior with the entire traffic around them by sending messages back and forth. These are standardized messages. A platoon with the messages developed by Ensemble is a separate entity in this CITS traffic. So they are connected to each other and they have the standard plus also new developed messages to create and share between the platooning trucks. In the CITS, there is no encryption because everyone needs to understand what is sending out. In Ensemble, when you have formed a platoon, it's encrypted, the messages that are shared, so it's secure messages, secret, and it's also so it's good for the cybersecurity there. It's a high frequency of messages, and in the CITS, it's a limited frequency, which is focused on the cooperative awareness. And the ensemble platooning is more focused on the safe but short time gaps that we can create with this vehicle-to-vehicle communication. The other function, the platooning autonomous function, there I already said there is no driver in the following trucks. That's why we say that the responsibilities, the legal responsibilities in this case, are only with the first truck driver, the safety of its own vehicle, but the first truck driver also has the legal responsibility to bring the platoon to its destination. So the mission of the whole platoon, and of course also to respect the traffic rules for the entire platoon. The following trucks, which are driverless, you can say there is a responsibility then for the system. And that's the responsibility for the safety of the own vehicle. The lead truck can, of course, not be held responsible for the safety of the following vehicles. So that's the responsibility of the system. It can do obstacle detection, it can do collision avoidance, and even if needed, for example, when the platoon splits up, you don't have a lead driver anymore then the truck can safely bring itself to a stop in a safe way and bring it to the side of the road. But of course, when you only have a driver in the first truck, a split of the platoon needs to be avoided in the first place. So that's why we are thinking about a more limited operational design domain here, where you can try to avoid at least the split of a platoon by, for example, traffic lights. So this is something that we have to see where it can be brought into practice, into the real life. And one of the main things that I already said is the difference with the autonomous function and the support function is that reduced time gap. But this needs to be done in a safe way. So what is needed to be able to do this and have a shorter time gap in a safe way? And the main part here is the brake performance estimation. As a truck, you need to be able to estimate the brake performance of the truck in front of you, what is the actual capability of braking, but also that of your own. And then comparing the two brake performances, it leads to either a short time gap, because you estimate that you're both able to brake hard at some moment, or if there is a big difference, the truck in front of you is not able to brake that hard for whatever reason, you can increase the gap. And as it says here, brake performance estimation is not that easy. It's actually quite difficult because it depends on a lot of different factors. And some of the factors you will know from your own system, your brake status, your tire status maybe the load is known from your truck, but the service type ahead is also, which is coming ahead, becoming a bit more difficult, and specifically when you're talking about road conditions, is the road ahead dry or wet or icy? This is all information that you need to take into account when you want to estimate the brake performance in a good and reliable way. All of these specifications of these functions we brought into what we call the Ensemble platooning protocol. So the platooning protocol supports both the platooning support function and the platooning autonomous function. And this is just one slide to tell you that it's an important step that we also brought this to the standardization bodies. So it's fitting already in the existing ecosystem of the ITS protocols, but Ensemble specifically also contributed to ISO, and we contributed to the ETSI technical report. So that's where this is also taken up for further standardization. And then last, but certainly not least, I would like to draw your attention towards the future impacts of the possible impacts of multi-blend platooning. Because in this arrow, you see that I talked about the development, I talked about the implementation, but in the arrowhead, you see there is lots more to know about multi-blend platooning. What's its impact on infrastructure, on the environment, on traffic flow, traffic safety? And all of this, what you can see in the arrowhead, that will be the main focus of our rest of the day for today. These are new results coming from Ensemble studies, and we are very happy to present you the results of each of those parts of the arrowhead, because together the technology and the impacts, measuring the impacts, that is in the end the value case of multi-brand platooning. Thank you very much, and looking forward to the rest of the day.
Thank you, Marika, for sharing with us some of the insights of the project. And I was particularly intrigued, I think, when you were comparing the PSF and the PAF, like we're sort of saying all the time, but the platooning support function versus the platooning autonomous function. Because it said the platooning autonomous function will really improve driver productivity and also the fuel consumption. So my big question would be, what needs to happen before we bridge that gap between PSF and PAF?
Yeah. Well, that's good that you asked that, because I think Ensemble already made a big stepping stone towards that autonomous platooning, but we're not there yet. And so what needs to happen to move further towards autonomous platooning? I think there's two things, at least, maybe more, we will find out, but at least two things that we need to look into. And one is the regulatory framework. At this moment, it's just not allowed to drive with a 0.3 second headway, as we would like to do, for example. It's just not allowed to take the driver out of the following trucks, even though we might be able to do it technically. So that's a part that is always difficult, and we will be talking about this a bit later, I guess, but that's one of the things we need to solve as well. And then there is that part which I touched upon briefly, that's the brake performance estimation. We can only bring this to real-world driving if we can do it safely, of course. Yeah. And that's where the chicken and egg problem is. Of course, it's not allowed yet to drive with 0.3 seconds because we cannot be able to do it, promise to do it safely, because we need to dig into that brake performance estimation and do that. And as soon as we can do that with all of the trucks in the platoon, I guess then we can safely go back to a shorter distance.
Thanks. That's a great explanation. I think also that we'll be touching upon some of these issues later today, like you were just saying. I can also see that we have some questions from the audience. I'm going to briefly flick through it to see if there's anything that we can answer right now. I see here something. Have there been some technological breakthroughs that would bring the business case closer? I think we're going to address that also in the afternoon, so maybe we leave that for now. Yeah. Yes, okay. I think most of these questions will be answered during the day, so I'll leave you with this cliffhanger. And I thank you, Marika, for your presentation.
Great. And just one thing, if it's not answered during the day, we will make sure everything is answered to everyone in the chat function.
You realize you're sort of making a personal pledge to the audience, so that's going to be loads of homework.
I'll ask some colleagues to do that, yes.
That's commitment for you. Thank you, Marika. Good. And we're going now to a different part of the program. As most of you probably know, the ENSEMBLE project was co-funded by the European Commission. And I feel really honored that we have 4 representatives here with us today and I'll be talking to them in our keynote roundtable. Hello, welcome, welcome. I'm really glad you're all here. Let me briefly introduce you by name, and I don't want to mispronounce titles or DGs, etc. So I'll ask you afterwards to shortly just say something of the relevance of the DG that you're working in relation to truck platooning. But we have here at the table Mr. Patrick Mercier-Handyside, Ms. Ewa Ptazinska, Giorgio Soros, and Anthony Lagrange. Welcome. I'll just start with you, Patrick. Can I ask you to just briefly say which DG you're representing?
Sure. So I'm Patrick Mercier-Handyside, as you mentioned. I'm coming from DG Research Innovation in a unit dealing with future urban and mobility systems. And I'm particularly responsible, among other things, about road safety activities, transport.
Ah, okay. Thank you. Safety, important. Yeah.
Yes, good morning. My name is Ewa Ptaszyńska and I'm Deputy Head of Unit responsible for road transport policy in Directorate General for Transport and Mobility. So I had a chance to observe and contribute to the evolution of road transport policy from the purely market-oriented and road safety-oriented objectives, shifting to a social dimension of the sector, to now looking into the promises that automation and digitalization can bring to the road transport sector. One perhaps thing to mention, I had a chance to spend one academic year at the University of California in Berkeley to work on a research project on impacts of automated and connected driving technologies in the driving sector. So I'm not claiming I'm a CAD expert for these technologies, but I'm certainly a big fan and believer that they, if appropriately applied, they can contribute to making the transport sector safer, less polluting and more resilient. And thank you for having me.
Great. I feel many questions sort of coming up about the policy and about also your experience in the US. But I think we'll touch upon that a little later in the round table. Thank you. Welcome. Mr. Soros.
Yes. Hello, good morning. My name is George Saros. I'm a project manager in the Horizon Europe Transport Unit in SINEA. SINEA is an executive agency established by the European Commission and actually is responsible for the operational part of the project. And I'm dealing actually with the projects in automated road transport. And in particular, I'm the project officer of an ENSEMBLE project.
Ah, so you have a lot of insider knowledge.
Yeah.
Good. Mr. Lagrange.
So Anthony Lagrange, DG GROW from the mobility unit. So in DG GROW we are mostly responsible of two things. The first thing is industrial policy, so how can we improve the competitiveness of the automotive industry. And second one, we are responsible of the vehicle approval legislation, and in this respect I'm team leader on automated and connected driving and safety. So that includes the platooning topic as well. Yeah.
Well, great to have you here. I think we just touched upon that briefly, so I'd love to hear a little bit more from you later as well. But maybe starting with you again, Mr. Mercier-Handyside. Also trying to connect the multi-brand platooning, how does it actually fit into the innovation and research or the research and innovation of transport agenda?
Thank you for your question. I would like, first of all, to recall a little bit the history where, in fact, ENSEMBLE comes from.
Please.
Instead, as it was mentioned by Marika in our presentation, all started around the Dutch presidency of the European Union back in 2016, where there was different events which were organized by the Dutch presidency. First of all, there was a big event organized in Rotterdam, the so-called European Truck Platooning Challenge, ETPC, which still going on now with some meetings with different stakeholders, being Ertico, CEDAR, or stakeholder organization. During that event, which was in April 2016, 6 platoon of trucks coming from different countries went to the port of Rotterdam in a convoy to bring their final destination in the port of Rotterdam. Such cooperation was very important at that start because it has seen as vital to to prevent the countries from creating a patchwork of rules and regulation. And we come at the end of this project about the recommendation and the follow-up in terms of regulation with Anthony at the end of his speech, which could have hindered the different manufacturers at that time on road users from investing in community-adopted vehicles. And this was followed after this event in June 2016 with a meeting of the Minister of Transport, where they came on a resolution on connected and automated vehicles. So it was a strong push from the Dutch government with all the EU member states at that time. And now moving forward to the research framework program. We wanted to support also these activities with research innovation activities to follow up on that, because there was no real test in real life at that time. So we have invested within the Horizon 2020, which was a research frame program at that time, going from 2014 to 2020. And we have launched the ENSEMBLE project at that time. So we have put on the table more than 350 million euros in research and innovation in the field of automated road transport. So we have launched, the strategy was to launch different large-scale demonstration projects on different sectors for cars, for trucks, and for urban vehicles. And in September 2016, we launched a big project, a top call for projects. And ENSEMBLE was a result of this call for project on multi-brand platooning in real traffic conditions. So it's a result of this 4-year discussion on implementation that is going to be presented here today. We have launched, in the second call, a topic also in 2020, more in the field of logistics. And there was a topic which resulted from this call on efficient and safe, connected and automated heavy duty in real-life condition, called AWARD, that also my colleague George Saros is managing. And I wanted to mention that as well there was several projects in the field of 5G technologies for CCAM application that has been launched in the field of logistics. Thank you.
Wow, thank you for providing that context. So that we have a better understanding as to also how that fits into the roadmap. And I think probably a somewhat similar question to you, Ms. Plesinska, about how that fits into the policy roadmap.
Road policy roadmap. General EU policy, I might say. Indeed, platooning is actually an interesting case of, or use case of application of connected and automated driving technologies in trucking sector. It has a bit of a history already, because as far as I know, it's been tested for more than 2 decades. And Patrick here mentioned the European Truck Platooning Challenge in 2016. Before that, we had a first EU-funded project called, if I'm not mistaken, Chauffeur. In 1996, where there was a first test of 3 trucks following each other in very close distances in southern Germany. So, but now when we ask ourselves why platooning? Platooning was developed not because the innovative technologies have become available, but because there were concrete road transport problems that we needed to sort out. And one of them at that point, the key issues, the key challenges at that time were insufficient road capacity. So they need to reduce road congestion and improve road safety, of course. So the idea was that as we cannot build roads indefinitely, we need to do something to make better use of the existing road network, to reduce the traffic congestion and to increase lane occupancy, making the traffic more fluent and reduce, of course, also risk to road safety. So these actually challenges continue to be relevant already today, still today, sorry. But of course, new challenges have come to the spotlight. And one of them is, of course, the need to reduce CO2 emissions. We all know that trucking sector contributes, I think it's 1/4 of all CO2 emissions coming from road transport comes from trucking sector. So they need to reduce this environmental impact, but also needs to improve working conditions in the trucking sector. So these needs translate into EU policy objectives, EU road transport policy objectives. So connected automated driving technologies and platooning as one of the use cases, I strongly believe that they have a very huge potential to address these issues, and by this, of course, to contribute to general EU policy objectives and contribute to road transport policy objectives, where, if I would like to put it into one sentence, is to create smart, safe, sustainable and socially responsible transportation system. So we will be talking about the benefits that those technologies promise to bring, like in terms of road safety, in terms of environmental impact and fuel efficiency and road capacity. But just to wrap up, you ask about how it fits. It fits very well with all the promises of improving road transport from different angles. It fits very well into the objectives of the EU Green Deal, of greening the transport and mobility, of the objectives and priorities of Digital Europe strategy, Road Safety Vision Zero, as well as a smart and sustainable mobility strategy. In the latter, we have a long list of initiatives that the Commission has committed to deliver. One of them is mentioned already here, ITS, Intelligent Transport System. We have a directive and the revision is envisaged under this strategy. But in fact, I wanted to say that the platooning is a very good use case to illustrate that communication technologies can come together and should come together with automation technologies. And perhaps contrary to what we have heard before by Marika, I strongly believe that CITS can really enable and even speed up higher levels of automation in the trucking sector. And to close this part, I would like to highlight, however, that to bring technologies to the market, it's not enough that technologies are mature and that there is a business case. The law must also be ironed out. And I think it was already mentioned also by Marika in the response to your question.
Yes, well, and thank you also for sort of re-emphasizing that point, because I think it's one of the important elements that sort of is standing between what we currently know and what the dream is. And you mentioned a lot of objectives that are very worthwhile pursuing. So let's see how we can get there. So thank you so much. And I was also listening to you thinking communication, automation sort of brings to mind standardization, because we need to be able to talk to each other. And I'm going to surprise the audience a little bit because I'm moving over to Mr. Lagrange now. They were expecting Mr. Saros to say something, but I have a question for Mr. Lagrange. Because talking about that multi-brand standardization effort, what were your initial expectations of the achievements around the standardization?
Yes, so I think Patrick already alluded to it. It didn't come from yesterday. That's quite a long-term project. I mean, as a follow-up of this impulse given by the Dutch presidency, very good impulse in 2016, the Commission adopted a strategy in 2018 on automated connected mobility. And the whole idea there was to make the link indeed between what is done, for instance, on the research side and what is done more on the policy and regulatory side. And I think that one of the key elements of this strategy is indeed this ENSEMBLE project. And the whole starting point was that, to echo what my colleague said on the business case, one of the big challenge was this interoperability of platooning across different brands. So that was a key enabler, because transporters don't want to be linked to one specific brand. And one key element was, of course, these trucks should be able to speak to each other when they go on platoon, and that was indeed the main idea of this project. As part of the same strategy, we also included some regulatory activities that are linked to that. So what we propose to the legislator is that when basically the ENSEMBLE project will be finalized, then the standard that could be the deliverable of this project could then be referred to in the approval legislation for vehicles. And therefore, we have now this empowerment. So in 2019, legislators said, okay, look, Commission, when you are ready, please legislate on this communication protocol between trucks for platooning so that we can have an interoperable system. So I'm really happy now to see that we are coming to some concrete outcome on this project. And of course, the next natural steps will be to refer to these standards in the EU legislation on vehicle approval. This will need some steps, of course. We will need to consult on that, but since we have the empowerment, it could be relatively quick. So it really depends for me on how mature this standardization work is. But if the standard is ready, then it takes usually something like 1 year to make it mandatory in the legislation for the sale of these vehicles. When I say mandatory, I don't think the idea is to make platooning mandatory, but it's more to make the standard mandatory. If you want to make a platoon, then you should respect this standard to put the truck on the market. So this is the situation. We hope that the deliverable is ready to go, plug and play, I would say, and we are ready to include in the legislation. What I just wanted to say is that, and I think it was also referred to by Eva on that, vehicle approval is one thing. This is one part of the aspect, and of course that's very important that we have this interoperability across vehicles. There are also many other regulatory issues. So I think it was mentioned by Marika at the beginning, the traffic rules process that are the responsibility of the member states. So there is some work to be done there as well to allow that these trucks are able to go so close as it is the case for platooning. So there is still some homework, let's say, also to be done by the member states to allow that. It's not only the vehicle, but we all have to work together so that it becomes a reality on EU roads in the future.
Wow, thank you very much. I mean, that sounds really promising. But also our colleague Carlos Logan will be explaining a little bit more about the deliverable and the state of the deliverable. But it's great to hear that there's enthusiasm around this table as well to take that a step further. So thank you for saying that and mentioning that to us. I'm getting really excited. Okay, and we're also sort of cutting ahead of the agenda because sort of the afternoon was for the future, but now all of a sudden we have a little bit of the future, a glimpse of the possible future at the table. So it feels kind of strange, but we're backtracking a little now with the question I wanted to ask Mr. Saros, although it might be in line with what we've just been discussing. What were the, you're being the insider or insider to both roles actually, what were the main achievements of the Ensemble product you reckon?
Yeah, actually the technical implementation of Ensemble project actually has been concluded. So we can say that after 4 years, Ensemble achieved quite significant results and also improved the understanding of platooning and accelerated the development of specific technologies. We have seen in the video before this demonstration, the public demo organized back in September 2021 in Barcelona. And as a project officer, I would say that of course, due to COVID, I mean, a lot of issues actually have been inserted into the project on top of the technical challenges that the project has to deal with. Because as you know, there were many difficulties to move from one member state to the other, so it was difficult actually trucks to move from one member state to the other, and actually to realize a demo with the seven brands. Actually, for me, it's something really a real achievement of the project. Now in Barcelona, actually, it was checked these two functionalities, main functionalities, the platooning support function, where actually it shows that it can offer a safer driving for platoons on road network. I think we have all experienced, I mean, while driving on the motorways, that we can see trucks driving very close to each other, but without this...
Almost in a platoon.
Exactly, but without this support, which sometimes actually violating the regulation and the safety. Yeah. But with this functionality, actually, we would say that this would offer, I mean, a safer driving on the motorways. The second one, and actually this is something that we can say that it's most promising. It's about the platooning autonomous function. So this actually gives the vision of the platooning for the future, because it considers that there will be only one driver in a convoy, for instance, of 8 or 10 trucks, there will be only one driver on the leading truck, and then the following trucks actually will be without drivers. So it means that all trucks actually will follow the guidelines and the instructions of the first truck.
It's an impressive image, eh? If
Yes,
you sort of think
definitely.
about this. Yeah.
Definitely. So that's why, of course, I mean, a lot of tests needs to be done.
Yeah.
I mean, it's not something that can hit the road, I mean, tomorrow. But in Ensemble project, actually, they have prepared the specification for such functionality. Also, Ensemble has prepared some studies about the impact of platooning. And I would say that road authorities also can benefit from this platooning, as the integration and also the uptake of the platooning would be also an important aspect for the digitalization of vehicles and logistics. And on this point, the road authorities could potentially actually influence some of the parameters in order to allow a convoy to move on their network. From economic analysis, I would say has shown that there is a direct business case actually with platooning autonomous function, and I think this will be also discussed later on. And for the platooning support function, there are of course benefits, but mainly on the societal aspects. The positive effect of truck platooning, I would say, on road capacity increases when the number of trucks actually is increased. Now the analysis is that it goes up to maybe 20% of the total flow. But however, on the other hand, there is a negative effect on merging areas. Merging areas means that when we have many on-ramps, so we have flow coming with a lower speed, then in this case there is a negative effect. And just to close my first intervention, we actually should not forget that truck platooning holds great potential, I mean, to make road transport safer, greener, and more efficiency. And in this project, and I would say that it was not given from the beginning. I mean, we will see that all the major stakeholders are present, and especially the trucks OEMs. So almost the 95% of the market is present in this project. The major suppliers. So actually, this means that all the major stakeholders shown the interest to this direction in order to bring platoons in European roads.
Wow, that's sort of a great closing statement, and I think we'll also be touching upon that the type of stakeholders and everybody that was involved a little bit later today. But it's good that you already sort of put it out there, so that actually all the people that are listening and tuning in today feel recognized, because I think a lot of them are actually also watching today that participated in the project. So thank you for that. I wanted to go back to you again. Again, a question about how it fits into context in relation to the plans that the Commission has with heavy-duty vehicles. So what should be the uptake of the Ensemble outcomes in that respect?
Thank you for your question. As you could see today, there is a real comprehensive approach in terms of CCAM, what we call CCAM now, Cooperative Connected Automotive Mobility. We don't speak about automated road transport only, but really the link with CITS is really there. And you could see with this round table that we have a very comprehensive approach between transport policy, research activities, but also standardization, and also something that you mentioned also, Eva, all the societal and ethical aspects that we should not forget as well, because we will put some driver out of the trucks and there could be some consequences, social consequences that we have to take into account when we speak about platooning or CCAM, more generally speaking. In terms of research innovation in the future, after Horizon 2020, we have launched Horizon Europe, which is a new framework program for research and innovation, and we have a dedicated activity on mobility, climate and energy. So we have combined this time all the aspects linked to transport, mobility, but also with energy and climate. So strong focus on climate, but we don't forget ITS and CCAM, of course, and I will come back to that in a second. All the road transport research activities in the future will be operated through different activities, collaborative research in one side, but also what we call partnerships. So in the field of CCAM, we have launched a dedicated public-private partnership in this field of CCAM. So this is important to know that all the industry representatives are working with the European Commission together with a big community of stakeholders. So it is industry-led from the other side, but it includes all stakeholders. When I say all stakeholders, it's road operators, researchers, legislators, NGOs, etc. So all the whole community working in this field are working together to implement the different systems on the CCAM. So in total, for Horizon Europe, there will be €1 billion, 500 million euro coming from the Commission, and 500 coming from the industry side. So it's a huge amount of money. So an increase compared to the past as well. We moved from 350 to 500 million euro from the Commission side. So a big increase in this sector. In the CCAM partnerships, it's a huge partnership with, at the moment, more than 160 partners working together in the different sectors. Only just to mention that the logistics sector is not so well represented, so it's a message here today towards the work. Yes, we have nothing to sell, but I think it's a message today also for the follow-up of ENSEMBLE. If all the logistics companies, the truck manufacturers could be more involved in the sector, to implement and to maybe deploy all the systems which have been developed within this project. An important message as well is that we, within the CCAM partnerships, we have launched two main activities. The first one is the development of a SRIA, a Strategic Research and Innovation Agenda, where we will develop and implement all the research for the next 7 years. So, and all the community of stakeholders went together to work on that. And again, one of the main activities will be to launch large-scale demos in different types of activities, but heavy-duty vehicles, trucks are not forgotten, and will be involved in different aspects, for example, on automated logistic operation, logistics in hubs, and also up-to-hub corridors, or the last-mile operation, more for the city logistics activities. We have launched different topics already in the first call, and I think George will come back to that. So we have different work programs, so I will not go in detail, where logistics is included. And we are preparing now the work program 23-24 for the next year, and we hope to have some project related on topics related to logistics. And just to conclude now on your question, for the follow-up of ENSEMBLE, follow-up all the research we have done in the past year, I think the time now is maybe to go to deployment. Not so much research activities, but I think it's really, and we went on standardization. I think this is two main message I will give today is standardization on deployment. I think it's really time, and we have some funds in the European Commission to support these activities, for example, the SAFE program. And for the future of research and innovation on heavy-duty vehicle, it would be important, I think, as I mentioned previously, that the logistics operators and also the truck manufacturers are working more together in this community of stakeholders if they want to see more activities in the sectors going on. So it's a message today. And the last message, we spoke a lot about also greening, with the Green Deal. I think it's important also to link all this aspect to other aspect of transport linked to energy efficiency and decarbonization. So there are new concepts, for example, the electric road systems would be connected with platooning or CITS activities, and it could be the future for the truck and logistics company to work together in this domain.
Thank you. It's great to hear that it's such an integrated or integral approach, touching upon the different objectives and the different stakeholders. And I almost take it personally because my background is actually logistics.
Ah, perfect.
So maybe I need to call some of my friends and tell them to come on board, especially when we're talking deployment, because then we need to have the rubber hit the road and move those logistics providers or service providers into the right direction.
Indeed. Yeah.
Thank you. I'll take that call home, and also for people back home. So we've looked at Europe, and you briefly mentioned in your introduction that you also have been studying in California. So I was just wondering, outside of Europe, do we have any partnership? What is going on that might be relevant to also mention here at this round table?
Well, here I would rather share my observations because it's my colleague Patrick who knows a lot about this international cooperation in this context. But indeed, countries across the whole world are testing connected automated vehicles technologies and truck platooning. And now they of course have different approaches to regulating the design, the adoption, testing and deployment of those technologies. And it's important, very important to exchange this knowledge base and this experience between those project teams, because at the end, transport sector has a cross-border dimension in majority of cases. So yes, my experience in US was, indeed, I had this first-hand experience in a truck platooning test drive. There was on public roads in California, and there was a project actually managed by, delivered by PATH. PATH stands for Partners for Advanced Transportation Technology, which is the program in the University of California in Berkeley. And there were some partners from Europe involved. The test drive that I have seen focused mainly on the technical issue on how this communication, V2V communication works. In my view, it worked pretty well. We had one or two cut-ins between the trucks, and I myself experienced how the following truck actually disassembles or just breaks to make the space for the cut-in vehicle. So as far as I know, PATH was also successful in applying for from US funds from Department of Transportation for another international huge project, large-scale platooning testing with highly automated trucks at L4 level, so following trucks without the driver or at this testing phase, I think safety driver only. So I know that this was developed together and implemented together with partners in Singapore, and the Japanese and European partners also signed up to it. I don't know exactly the details of how this project went, but this just shows that there's really intercontinental even opportunity to cooperate in this field. But I just wanted to mention, and Patrick, correct me if I'm wrong, that EU and US has really long-standing cooperation, which is governed by the Agreement for Scientific and Technological Cooperation. And in 2013, United States Department of Transportation signed with European Commission the bilateral implementing arrangement for all kind of cooperative activities in the field of research, technology, innovation, covering all modes of transport. So this is important because it provides also the framework for twinning partnerships between different research teams, organizations on both sides of Atlantic, in order to exchange the knowledge and experience and exploit synergies. So, and then Patrick already mentioned Horizon 22, now Horizon Europe, which of course provides funds for such twinning projects. And on the other side of Atlantic, we have funds from Federal Highway Administration of the US Department of Transportation. And as far as I know, this Federal Highway Administration, together with ENSEMBLE, established such a twinning partnership in 2018, right? Which indeed allows the groups to coordinate and exchange information on their research questions. And what's very important, and was not, or was just briefly mentioned here in the discussion so far, is that the focus is now on traffic interactions, on behavior of our other road users, because road safety is not only about how the communication works and how the truck drivers behave and how well they know this advanced driver adapted systems, advanced assistance systems for drivers, but also how other road users behave, how they perceive these convoys of trucks. How they understand it and how they behave. So I think it's very, very much important for deployment of platooning. Public acceptance is really something that we cannot ignore.
Absolutely, and that will definitely be part of the afternoon program, because that I also find one of the interesting finds in this particular research is sort of the human factor. So how is this road user impacted? If we take it out of the simulator, then how is that going to work out? So thank you for bringing the rest of the world in and also showing us that it's not just Europe that is working on this particular topic, and that there's a lot of relations already established that will speed up also the learning that we have to do. Then maybe go into to build a little bit on the deployment agenda that's sort of laid out for us. So we have some of the experience now, and how are we going to get it to the road? And I'm looking at you, Mr. Saros. What do you think the main challenges are now to really get it to the deployment?
Indeed, I mean, in Ensemble project and also in other initiatives actually implemented in Europe, they have provided some first results. But of course, there are a number of challenges that need to be tackled in order to pave a way for a large deployment in Europe. Apart from the regulatory framework, which of course my colleague Antoine will mention, I would say that also further development of the platooning technology and also the relevant standards is an important aspect. Another important aspect and challenge, which is I highlighted before as a positive point for Ensemble, is to bring together all the relevant stakeholders, meaning road operators, OEMs, insurance companies, policymakers, so all the different stakeholders sitting on the same table and discuss this point. And the involvement of these stakeholders actually can bring and will help to identify the value proposition of the truck platooning, which will help also to build up, I mean, the business models. What, of course, we should not neglect is the role of the driver. I mean, this is something that it has been discussed not only in Ensemble for truck platooning, but this is, I think, a discussion for the whole community. What will be the role of the driver in the future because of the introduction of automation in vehicles. Mm-hmm. For instance, there is a lot of discussion about the taxi drivers, about the logistics operators. So this is something that also here, I mean, for professional drivers, like the truck drivers, needs actually to see, I mean, what new skills maybe related to platooning can also be trained, I mean, the truck drivers, in order to somehow shift their role from the driving maybe to other activities. The public demo in Barcelona also showed that this type of events, it would be useful to organize it all over Europe. If you want, I mean, actually to embrace this technology, this new concept, I mean, into European roads, we need to test it. And we need to test it extensively in different locations because, first of all, weather conditions are not the same the north part of Europe or the south part of Europe. And also the traffic rules and the traffic behavior of the driver is not the same in all European countries, as we all know. So it is important that a number of lessons learned and actually the project coordinator, and I'm sure that also the rest of the partners will share with us today that a number of lessons learned have been brought to the project through this public demo in Barcelona. Also, from these demos, we can also see whether some also changes need to be made, for instance, on traffic management. Do we need actually to update the established rules? We need to actually discuss about the new traffic rules. The cross-border and the interoperability, which was mentioned before, we need to make sure that a platoon starting, for instance, from Italy, coming here to Brussels, should not actually somehow disconnect it somewhere in between. So we need to make sure that there is a safe and also interoperable connection and travel of the platoon within the member states. Another challenge is that is the current concept and the current road infrastructure are ready actually to embrace this new technology at a large scale, and also the current set of specifications are well defined so that the road operator will accept a convoy of 10-15 trucks to move in the road network. Because of course, as you all know, also the road operators have the rules. I mean, how actually we need to move. I mean, in the road network. So all this has been well considered in order to run such a concept at a large scale. And also what my colleague Eva mentioned before is the interaction, I mean, with other road users. This is important. Also, we have seen it also in Barcelona that there was this Catin vehicle, I mean, in the convoy of seven trucks. But also we need to, and actually the stakeholders need to see how this new concept the interaction with other road users, and not only with a human driver, but also with other automated or non-automated vehicles, because in the meantime we will be in a transition period where conventional and automated vehicle will be on the same road network. So this is actually one of the, let's say, big challenge that we need to tackle in the future. But I'm sure that later on, I mean, in the panel discussion with different stakeholders present, I think that maybe some of these challenges will be discussed.
Yes, I think so. And I think excellent summary of the work that still needs to be done. And I also liked your existential question almost about the role of the driver. How will that evolve in this new setup almost? So thanks for that. Maybe to finish our roundtable, I'm looking at you again, Mr. Lagrange, because I think if we're talking deployment, then the regulatory framework has an important role to play. And I think you already touched upon it in your previous answer, but maybe you just want to give us some few final remarks to close off the roundtable.
Yes, so indeed I spoke about it. So we are happy about this deliverable. We are happy to look at it more closely to include it in the legislation. I think I mentioned it, and it comes back to what you said. There are also some other regulatory challenges, in particular traffic rules within the member states that could indeed be adapted in particular to tackle these challenges of interaction with other road users, for instance. Maybe I will broaden a little bit the perspective on that, because I think you mentioned it in your introduction. So we have this platooning support function, and this is what I talk about mostly in terms of regulatory framework, but be aware that the same regulation that we adopted in 2019 also empowers us to regulate on the automation aspects, so automated vehicles and fully automated vehicles, and we are full speed working on this implementing rules now. So we are preparing rules for the approval of fully automated vehicles, so driverless vehicles. So that could be indeed a good combination between the platooning support function and more the automation function. For this package on fully automated vehicles, the goal is to have the rules in place by summer this year, so it's already quite advanced. But indeed, I guess it could also open up new perspective also for platoons. So this advancement on automation. Also, not to forget the development on electrification on trucks. That could be indeed very important. And I guess maybe here it could also bring a case for platooning, because as you know, for electric vehicles, aerodynamics is quite key and even more important than for combustion engine. And indeed, maybe platoon has a role to play in this development as well. So that's also something we need to take into account for the future and follow-up of this project.
Thank you, and thank you for broadening the scope and almost ending with some cliffhangers there. I'd like to thank you all for your participation in the roundtable and for providing a European Commission perspective on this very important topic. Thank you very much.
Thank you for having me.
Thank you very much.
Now we're going to Mr. Christophe Rombout. He is working at the MOW. and will share with us his take on what the role is that Flanders would like to play, the region Flanders would like to play in taking up truck platooning.
Good morning, everybody. Very fine to be here this morning, and really nice to hear some of the aspects that come out of the panel debate. I'm sure with what I will bring, you will also see that some elements will be reiterated. It seems like only yesterday that we were here together in 2016, demoing the single brand platooning and signing the Declaration of Amsterdam. That was a declaration that for connected and autonomous driving basically put CCAM on the perspective also of our political leaders, of our transport ministers, that they were expected also to take action in this domain, in one of the domains that they are taking action. And in preparing for this, I thought it's actually hard to believe that already 6 years have gone by since that time frame. And in those last 4 years, that new standard for multi-brand platooning has been developed. I have to say it's really impressive to see the good cooperation between all the stakeholders and the drive in pushing this technology forward. And indeed, my conclusion at least was time really flies when you're having this much fun. Now for the serious part. In Flanders, Flanders is known as a logistical hotspot. And indeed, some of our highways have a really high density in terms of occupancy by trucks. Actually, if you drive on the E17 today, in some times of day, I have already instances where I thought, is commercial truck platooning already deployed? Even years ago, because you can see sometimes that trucks drive really close together with a gap of only a few meters. And this is without all the communication technology, either vehicle to vehicle or vehicle to infrastructure, or without higher performance brakes, as sometimes are applied within truck platooning as well. Obviously, these circumstances where you have a very high density of exiting and joining the highway is posing some challenges and even can cause some dangerous situations. This is the situation today as it is. And I can say in 2020 in Flanders, unfortunately we could observe more than 400 accidents involving trucks on highways. 22 of those have resulted in fatalities as well. And although the trend in accidents involving trucks is decreasing, every victim that we have to mourn is one too many. To tackle this issue from a wider safety perspective, Flanders put forward a road safety plan with a horizon until 2025. And this contains several objectives. Two of those objectives I would like to debate more in detail because they specifically relate to this project, to the ENSEMBLE multi-brand project. The first one being, as a government, we want to have continuous attention to innovative transport technologies and innovative vehicle technologies because it brings new possibilities to increase safety. Second aspect is the infrastructure itself. We want to have a safe and well-maintained infrastructure. I'll start with the first objective and elaborate on this one. In Flanders, we are convinced, in general, that vehicle automation has the potential to drastically reduce the number of accidents and the severity of accidents. And this is the whole theory that we know that in 90% of the accidents, human error is playing some role into the occurrence of the accidents. We believe automation can reduce that human error, and that's one of the reasons why we are also actively promoting the usage of advanced driver assistance system. That is, on one important condition, that the conditions under which these ADAS systems are working are very thoroughly explained also to the customers of the product, to the chauffeurs, to the drivers of the product. When is the automation working? When is it not working? And that they need to understand the boundary conditions. That is for us a fundamental principle. I think there's also a responsibility there for the constructors, but also for the public sector to inform the customers, the drivers of those technological aspects. And in that context, multi-brand truck platooning is by us seen as a front-runner CCAM application. It kind of symbolizes the mobility revolution which we are witnessing today. And this is not just from a technical perspective. In a post-COVID-19 mobility system, we can see that the public expectation of what a mobility system would need to look like, should look like, has evolved. It needs to be safer, but not just safer. People are expecting it to be light years safer. It needs to have a much better throughput. It needs to be much more sustainable than ever before and way more inclusive than it has ever been. On another point, multi-brand platooning is also a textbook example of innovation. You can see that within these kind of projects, the role and the responsibilities of all parties involved within the truck platooning ecosystem are sometimes shifting. It makes it kind of hard to know in advance where we will land, and it makes it challenging to define what the following steps are that need to be taken. However, that is the nature of innovation. And we need to embrace that concept and interact more with each other than we have ever done to define what are those next steps. Just like the trucks are cooperating with each other in a defined standard within Ensemble. On the second topic, safe and maintained infrastructure, this project is learning us as a Flemish Agency for Roads and Traffic and as the Flemish Administration for Mobility and Public Works, the practical necessity of why we have to become next to the physical operator that we have historically always been. We now need to prepare also to becoming additionally a digital infrastructure manager. Now, we have already taken a few stepping stones in becoming that digital infrastructure manager. Firstly, we have a quite large investment program, 29 million euros, in which we are introducing CITS in Flanders, and that program is called Mobilidata. The main objective of that Mobilidata program is to deliver the sustainable digital infrastructure to deploy day one and day 1.5 CITS services. And for us, it's actually a first stepping stone to facilitate future CCAM services as well in Flanders. And know that in this program, we are also deploying intelligent traffic light controllers. I will come back to that in a few minutes. Secondly, and on a more strategic level, we have also looked at our operating model. What do we need to change within the NRAs, within the national road authorities or regional road authorities, on how to become that digital road operator? Is this a matter of technology, and is that the only thing that needs to change? We recognize from that aspect that digitalization brings new opportunities in terms of the services that we offer and in terms of the customers that we are supporting. Therefore, our conclusion was that actually all levels of the operational model have to be adjusted, from the mission to the services that we offer, how we are organized, which processes we apply, what kind of data housekeeping we have to maintain, and what kind of technological layers to require. What you have to remember from this aspect is it's more than just the technology. You have to have a look at all levels of the operational model to become a digital road authority, and there's clear links with this program as well. Now, what are the specific benefits that we see for Flanders from multi-brand platooning? Firstly, as I started the speech, we recognize that our road network has a very high density in terms of exits and entries, especially on ring roads. And we do recognize, as the panel actually said, that platooning as a support function in Flanders probably will be suspended more often here than in other countries. At the same time, due to the cut-ins and cut-outs. But at the same time, we do see the benefit of having the platooning function active, because it is also a way to increase the distance, the following distance between different trucks. And it is this following distance that is basically determining to what level other road users have occlusion. Can they see what is happening at the exit? Can they see what is happening to join the motorway? So there we see clear benefits in the support function from a safety perspective. Second point is, in Flanders, we also have a number of very important economical hubs. Think about our ports as well. Their platooning can definitely increase the productivity of logistical flows from the port to the hinterland and vice versa. So efficiency gains in terms of the economical perspective. Thirdly, in terms of reducing harmful emissions, and I know this is kind of a debatable topic. Is there really fuel efficiency gains? Is there really CO2 gains? Well, we believe under certain conditions there definitely will be. If a platoon needs to cross a traffic light regulated intersection and the trucks do not need to stop, the fully loaded trucks do not need to stop, but get priority under certain conditions, under certain geographical areas, we do see that it is possible to reduce harmful emissions and reduce CO2 in specific environments such as harbors, ports, and the likes. That being said, and considering that the saturation levels on our Flemish road network, especially on the highway, we also need to mention modal split. We also have to make sure that our roads are not further saturated by introducing new technology. And that is one of the reasons why we're not only investing in autonomous mobility on the roads, but that we're also investing in autonomous shipping. The waterway also needs to become more competitive so the modes can compete with each other. On another element, the imminent introduction of level 3 autonomy in Europe, we can see happening in the coming months. There's the first use cases that make their way to the market, commercially developed. And we thought, let's have a look at how this could impact, this could evolve also the truck platooning use case specifically. We can see that indeed today we have a defined use case platooning support, and we have a full autonomous function that has been specified. There might be an in-between scenario where the driver is indeed under certain conditions, under certain speed requirements, taken out of the loop, which could increase safety and could also increase productivity of the driver. However, that also means the driver will need some upskilling to perform secondary tasks, and we need to think about what those secondary tasks then could be. From a regulatory aspect, we also recognize that there are things that need to be addressed. If indeed the tests are showing that driving fatigue has been decreased, then we need to consider having a look at driving and resting legislations. And last but not least, our Belgian legislation, current legislation, requires an update. We know that at least for level 4, it is already possible today to perform tests, to do experiments, but to deploy them commercially, that would require further adjustment under the Belgian level 4 regulation before those systems can commercially be deployed, and action needs to be taken from that perspective as well. That being said, and this brings me to the end of my debate, we would like to definitely congratulate the whole team on the accomplishments, both Ensemble as well as the European truck platooning community. And we are looking forward to debate together with you, with the conclusions on the table, how we can proceed to make truck platooning a reality also in Flanders.
Thank you very much, Mr. Rombout. I think you already touched upon it in your presentation. But in the interest of time, I'm still going to ask you, but I'm going to ask you to sort of give us a quick overview of the actions that you're actually already undertaking to facilitate truck platooning in the region.
Yeah, with pleasure. I think firstly, it's going to be important to look at the results, the outcome of the study in terms of when we look at the physical infrastructure, are there any additional requirements? Is platooning posing any additional stress on pavements and bridges? And how will this be impacting our maintenance schedules for pavements and bridges? That is the first one. Needs to be addressed. The second one is more on the digital infrastructure level. As I said, we have a mobility data program, and one of the use cases that we have retained, and this is, we started with more than 400 use cases, drilling down to 100, drilling down even further. One of the retained use cases actually is supporting providing priority to platoons at the intersections, traffic light regulated intersections. We have a number of technical people that, and this is in cooperation with our Dutch colleagues, by the way, that are looking at what kind of information does the traffic light exchange format, what kind of information do we need to identify a platoon is approaching, and then to provide this priority. So I think there is a clear action with the outcome of the ensemble. Let's have a look at what we have already done and how we can make those two positions match.
Great. Thank you so much for sharing this with us, and also for ending with this more sort of practical approach. Thank you.
Very nice to be here, and thank you for your time.
Then, let's have the rubber hit the road. We have been talking about future and about policies and about all sorts of interesting things, but now I'd like to talk about trucks on the road. And some of you might have been there in Barcelona when the real-life testing took place, and I'm really happy to tell you that right now we'll be sharing the results of those real-life tests. And with me is Delia Willemsen. She is a senior research scientist at TNO. And she will be taking you through some of the exciting outcomes of the real-life testing. Delia.
Thank you. Good morning from my side, but not only from me, also from Pablo Rodriguez, the involved work package leader. And let's have a look at the real-life testing that was done in the project. So let's go back a little bit to the objectives of the project, of the testing in the project. How and what was tested, and then, of course, the results and the conclusion. So the objectives of the testing was looking at the platooning support function, so the first level, is it working as defined? So validating the specifications we set up and the requirements in the project to really accelerate the standardization. So really you can prove that the specifications and the requirements you have set up, they can also work in reality. So for that we had to prepare and of course execute the testing, set up the scenarios, do the data, set up the data management, do the test management, and then of course evaluate all the results getting from that and have also feedback on the specifications and requirements. So how was the testing set up? First of all, the methodology had to be set up and the data management plan. Then we went into really testing. First testing was done in smaller groups. So 2, 3, and even 4 OEMs met up to do the testing. And then in the end, later back in September, we did the multi-brand testing, also went up to the public road, and we had the final demonstration. And then after that, actually the evaluation started, getting into the data, evaluating all the different tests, and then finally come to a conclusion about how the platooning support function is working. So towards the methodology, first of all, the test scenarios had to be defined. As a basis for that, we took the use cases that were already specified, the specifications for the function, looked also to the specifications for the communication and the interactions with the infrastructure. And based on that, logical scenarios were set up and also parameter spaces were defined. And this complete set of scenarios were taken towards different kinds of testing. And for the different test setups, different scenarios were chosen and parameter settings were chosen to do the smaller group testing, the multi-brand testing, and the open road testing. So for example, we did join from behind, leave scenarios, a vehicle cutting into the platoon, or emergency braking. And after the testing, all the data was gathered together and the evaluation was performed. So I wanted to put up this list of all the testing, really actual testing we did in the project. It's actually still quite a long list, even if you realize that this was done in the last 2 years. We also had the COVID virus. As you can see on the top of the list, there is it really coincides with the outbreak of COVID in Europe. And then we did have a chance to also have a small meetup, more of a bench testing back in Helmond. And if you look well, it's been really a year since we could start testing again. And then we formed actually two groups. One group more in Sweden, Volvo and Scania testing together, and one group that went to Germany and testing there, that was DAF, Daimler, Iveco and MAN. And yeah, it's still an impressive list, as I said. And finally, in the end, we met up in September in Spain to do the final testing, the open road testing and the demonstration. So what did we test it and how did it work out? Well, like I said before, yeah, you have to start with platooning, so you need to join from behind, either by a single vehicle or join from behind as a platoon. These went pretty well. Then steady state platooning, so really driving at constant speed. No nasty oscillations appeared, speed variations we did, gap variations, that went all very well. We also checked the interaction with the infrastructure. We could not actually test them all, regretfully, but what we tested went really well. Then, of course, dealings with the traffic around the platoon, vehicle cutting in or cutting through and also cutting out again. And that was also tested with positive results. And then stop platooning, so how to leave the platoon when you reach your destination but the other ones want to continue, or split the platoon when there's something going on, or when, for instance, the cut-in vehicle stays within the platoon for too long and you do not trust the situation anymore and you want not to follow that vehicle ahead anymore. And of course, emergency braking, a very important scenario, that when the first vehicle or vehicle in front has a very strong braking, that the driver gets the warning in time and reacts to it as well. But we also learned something different from the testing. First of all, testing cooperative technology with different implementations in different trucks, and when it gets more than three vehicles meeting up, it requires a lot of coordination and aligning, etc. Also looking really towards the technology of testing, the special logging for testing should be set up in parallel with the system design. Especially when you look at cooperative systems, a lot of more data is involved. You receive data from different vehicles, you want to log it as well. A whole lot of data comes together. And the interesting part was also going really onto the real road, testing in real traffic. And then you have toll gates and bridges, and they pose really extra challenges to the platoon, and of course the traffic around. We had more cut-ins than we actually expected to have, and that also made clear that the cut-in scenario is actually a really important scenario, but also another one, because when you split the platoon when there's a cut-in, also the scenario of join by a platoon is very important. And then finally, looking really into the system and going back to the first question, did we design the platooning support function well? Actually, yes, we did. So the use cases, the specification requirements, and also the communication protocol with the security measures also there, it all worked well and is technically feasible. And as that, the results are currently being taken into standardization.
Thank you, Delia.
Yes.
Well, that's actually a high to end on. So everything went well, all the testing that you've done. And it makes me wondering, what else would you have liked to test, or what else would you like to test, maybe in the future, to get an even better understanding?
Yeah, there was of course these were first time getting together with these systems, first time systems. A lot of fine-tuning needs to be done. For instance, when do you decide when you send a request to platoon to a vehicle in front? How long do you wait until this vehicle sends the accept? Or how long does it take to conclude, oh, maybe he's not working well and I should not platoon with this vehicle? And you need a lot more testing for that, as we did.
Yeah, so those questions are still on the table.
Those questions are still on the table, and of course these were also prototype systems. So, for instance, also looking into some details of the security we used, the signing and verification, that seemed to be computationally pretty heavy. So that needs more thoughts as well. We now use it on all messages that we exchange, and one message we exchange with 20 hertz, so 20 times per second. And that's a lot when also we want to sign and verify these messages. So maybe we have to do it in a different way.
Yeah. Still homework there. And I was also maybe looking back, wondering about, was there anything that surprised you during this entire process of testing that you weren't expecting?
Yeah, actually there was. We defined a very specific way on security. We used encryption in a special way, so with asymmetric and symmetric encryption and exchanging of keys. And yeah, when we were talking about it and designing it, I had a bit of a bellyache. Well, it's pretty complicated. I'm not sure. I hope it's going to work. And I was pressing like, yeah, be sure that we can also test without it. And I was really surprised it worked pretty quickly, without any much problems.
It's a good surprise.
Yeah, I
can
think they of course tested a lot online and in exchanging encrypted messages and trying to decrypt it.
Yeah.
But yeah, it worked pretty well, and it has been a lot of work by all the teams, and I want to thank them also for that hard work, also for all the testing,
that's nice. So halfway through, just a word of thanks. Yeah. And also, I mean, I promised the audience that we do questions, so maybe there are some questions for you, Daly, if you're up for that.
Yes.
Let's see. I have a question here from Francisca Gijena Sanchez from Aegis, and he asked you, I wonder if you need any specific dedicated telecom infrastructure in the highway besides the adaptation of trucks themselves to allow for V2V communication.
To allow for V2V communication, it says it is V2V, so vehicle to vehicle, and it's not depending on the infrastructure outside. Now we use the setup that's already been used in Europe. It's called ITS-G5. So it's already defined, and we build upon that. So it's there, and the results are also taking into the standardization of this ITS-G5. It's done by ETSI. And yeah, the vehicles themselves, they need devices to communicate with them, but it's ad hoc, so they do not need anything extra outside that.
No dedicated telecoms infrastructure?
Only the boxes in the vehicle and the antennas, of course.
Okay, thank you very much. So Francisco, I hope that is an answer to your question. And again, also to the viewers, if you have other questions, please let us know. Thank you, Delia.
Thank you.
Then we move over to a question that might be on your minds or might have been on your minds ever since the beginning of this particular event. I think it's been mentioned several times. Is there an effect on fuel consumption? And with us we have Nico Deschle. He is a scientist innovator at TNO, and he will share the outcomes of the research that he has conducted into this particular topic. Nico.
Yeah, thank you, Karin, very much for your introduction. Yes, I will be walking you through the results of the impact of truck platooning in fuel consumption and emissions. So let me first put a little bit this into the context of the project. So you might remember this slide, this picture from Marika's presentation. So we have in this arrow, this summarizes a little bit all the work from done in ENSEMBLE, and in the stem of the arrow is more the development of the technology, and on the other side of the other part of the arrow is impact assessment. And this particular task is the study of the impact of multi-brand platooning in sustainability. Okay, so to go a little bit further more specific into the objectives of this task, the objective was to identify and understand the different dependencies of fuel consumption and pollutant emissions on multi-brand platooning. To do this, what we did was to actually make physical measurements of emissions and fuel consumption on the vehicles. You can see in the in the picture on the left, so on the bottom left, there is a picture of the device that was the same device installed in all the different trucks from different OEMs to measure the emissions. And on the right picture is onboard computer that was in charge of logging all this data and time align it so that we can analyze it properly. The approach to do this research was to study two conditions. So we studied the solo driving condition and the platooning driving. And then the idea is to compare both to see what's the benefit. And furthermore, we did two tests. One test was in the test circuit, so that's a control environment, almost could be considered like as a laboratory experiment. And the other test was on the open road, and this is the real-world case where we have interaction with all the external factors. And putting the results of these two together, yeah, we basically can reach the proper conclusion. So I will first start with the results from the test track. So here you are seeing a picture of the test track from IDIADA, that's in the IDIADA facilities. This track has 7.5 kilometers long and about 0.3% of grade. Those are, of course, important things to have into account because this is important for the fuel consumption analysis. Yeah, so after we perform the tests in these two conditions, in solo driving and platoon driving, what we need to do before looking at the fuel consumption or emissions is to see whether all the other conditions were really similar or comparable, so that actually that will allow us to do the study. So we look whether the temperature of the vehicles was the same, whether the vehicles actually were driving the same distance before, etc. And of course, one very important thing in all this is to look at the kinematic variables, in particular the speed, to see whether the speed of the vehicles in the two conditions was the same. In this case, we found that the speed was not exactly the same, but the difference is small enough that it allows us to do the comparison. What I'm showing in this picture is the difference in speed for each vehicle in the two conditions, and in the horizontal axis is the position of the vehicle within the platoon. So you see it's more or less consistent that the vehicles in platoon are driving a little about 1.5 kilometers per hour slower. So after that, yeah, we can compare the results in the fuel consumption. And here what I'm showing is on the left, the same figure I was showing in the previous slide, but for the fuel consumption, for the absolute differences, and on the right is the relative differences. And what we can see here is that there is no significant effect for the leading vehicle, but we do see a consistent effect for the following vehicles that is about 1.4 liters every 100 kilometers, which accounts for about 7% reduction of fuel for the vehicles while platooning compared to the solo case. This result, and this is important, is very much in line what we can find in literature for the ACC case for fuel consumption reduction. So furthermore, I mentioned we study also the pollutant emissions. So we look at the NOx emissions for the vehicles, and we couldn't identify any clear trend. In the right, I'm showing actually the results. This is the absolute values for the different vehicles, and we see that, yeah, there is no clear trend associated with platooning or with the position in the platooning. And yeah, furthermore, if these results that I'm showing here are absolute values, but if we look at these in relative values, actually are very, very tiny, are almost negligible. Furthermore, yeah, what we can say is that actually what we are seeing is effects that are due to other processes like the SCR rather than an actual effect of the platoon. So to summarize the conclusion for the test track test, basically we don't see effect on fuel consumption for the leading vehicle. We do see an effect for the following vehicles that is about 7% or 1.4 liters every 100 kilometers. And there are small variations in the NOx that cannot be attributed to the platooning. Next, we go to the open road test. As I mentioned before, we did also a test in the open road. This is the real world test with interaction with traffic and different things in the road. And this was done also in Spain. In the left, you can see a map of this, where it's located within Spain, and on the right, you see a bit more detailed picture of the road. And this road actually is relevant to mention. Yeah, it's about a bit less than 100 kilometers long, and it has quite some altitude gain. So the altitude difference is about 400 meters, and the altitude gain in the whole route is close to 1,000 meters. So as we did with the test track, what the first thing that we do is to see if the conditions in the two cases were really comparable. And the first thing that we see in this case immediately is that the speeds the speed profiles in the platooning and the solo case were a little bit different. What I'm showing in this image is in blue is the speed distribution for the platooning case, and in green is the speed distribution for the solo case. In each of these panels is one vehicle. What we see immediately is that actually for the platoon, the variability of the speed was higher. Actually, the distribution is wider. But we also see that, as I'm denoting here with the red lines, that the average speed in each of these cases is quite different, and is close to 10 kilometers per hour, which is very significant. And this, will become a problem to study fuel consumption or emissions in relation to the platoon. But actually, we wonder, well, what's really causing this variation in speed? And we can dig a little bit deeper into this. And here in this picture, what I'm showing is the speed profiles of the different vehicles together, and below that is the altitude of the vehicles. And what we can see here is that the variation of the speeds between vehicles increases when there is a change in the grade of the road. And we tested this, and actually it's quite consistent. There's quite a big correlation between the change of the grade and the difference in the speeds among the vehicles in the platoon. Furthermore, actually, it's not only that we see differences in the velocities within the platoon, but here in the lower picture, what I'm showing is within the platoon management, how many vehicles each vehicle is seeing in the platoon. So we can see when the speeds are actually quite stable, this number remains quite constant. But when there are larger fluctuations in the speed, the vehicles see different number of vehicles in the platoon, which means, that there is some instability in the platoon in those particular situations. So basically, we can look at the fuel consumption for this case, and we do see that there is a smaller fuel consumption in the platooning case, which is about actually 3 liters every 100 kilometers. But unfortunately, we cannot attribute this to platooning because the conditions were such that, this actually can be due to the difference in speeds. So to summarize the results for the open road test, basically we see that in the platooning scenario, there is quite high speed variability, and there is also a lower average speed. And although we see a lower fuel consumption, we cannot attribute this to platooning. And then, thinking about the reasons of why there's a speed difference and speed variation in the platooning case, we can see that, of course, this can be a multi-brand platooning issue, that, for example, the different vehicles have different power-to-mass ratio. And then actually this means that actually the grade of the road plays a very important role. But also there are other effects, external factors that influence different the speed when a vehicle is driving solo or in a platoon. For example, toll stations or traffic can impact different in a platoon or in a vehicle driving solo. So before jumping to the general conclusions, one very important remark to how to understand the results for the fuel consumption in the truck. we have to take into account that these 7% that we see is actually a upper bound value, right? Because the vehicle is not driving always on platoon. Of course, there are different conditions in the road. There are tunnels, there are legislation, but also is the platoon opportunity case study, right? That we have to see, okay, from the logistics point of view, how frequent and how easy is to put platoons together in a platoon, and that's of course not 100% of the time. And well, this increase actually can have a penalty. On the other hand, the vehicles, when they are solo, we're in the results that we have in the 7%, we're comparing this to the solo case. But yeah, vehicles are never really driving completely alone. There's always, or almost always, a leader in the road or a vehicle before. And furthermore, one very important thing is that the current state of the technology is ACC. So actually, the baseline that we should compare to is ACC. So now, finally, to summarize all the results, we can say that, yeah, there is still a speed stability on multi-brand platooning that can be a challenge. That, yeah, for the platoon support function, we cannot really say that there is a fuel consumption benefit compared to ACC, because we see actually the same result that in the literature is found for ACC case. There are no significant effects in NOx emissions. But on the bright side, we can say that, well, this actually leaves all the potential for the fuel consumption and the sustainability of the platooning to the platoon autonomous function that remains to be studied. And yeah, this ends my presentation.
Thank you, Nico. I saw some questions coming in from the audience, but I think you answered most of them already in your presentation. But I have a question for you, because I loved when you said the bright side, the platooning autonomous function. And I was wondering, how sure are you at this stage that the platooning autonomous function will actually reduce fuel consumption?
Yeah, well, indeed, that's of course a very good question. And I said, yeah, on the bright side, because what I say is that it leaves a lot of potential for this, for the platoon autonomous function. And yeah, I think, well, I'm confident, or rather very curious to see these results. I think with the decrease of the time gap between the vehicles, this can bring not only a lot of reduction in fuel consumption, but actually with very small gaps, we can even mitigate for external factors such as traffic or this speed variability. So I believe actually in the way I see it is that with all this research that we have done, this leaves actually the field really ready for the platoon autonomous function to be studied. And I trust, I believe, I hope, I think that this will encourage us and fellow researchers to study the platoon autonomous function. But it's important to mention it needs to be measured. This is
no, I get you. But I also see sort of the hope glimmering in your eyes, like there is something there. Start researching, to all the people. So thank you so much for this.
Yeah, thank you very much.
Next, you might have already noticed, but we have moved in with the presentation of Nico into the part where we're talking about the impacts of truck platooning on various aspects. So fuel consumption is one of them. And the next presentation will be about the impact of truck platooning on traffic flow. So how is it actually influencing what's happening on the roads? And to take us through those outcomes, through those results, is here with us Kinjal Bhattacharya. And he is a postdoctoral research fellow at the Université Gustave Eiffel. Kinjal, take it away.
Thank you, Karine, for having me. I'm honored to make this presentation on behalf of my colleagues at University Gustave Eiffel and TNO. So for the next 15 minutes, we shall be talking about how these kind of multi-brand truck platoons affect the traffic flow and traffic efficiency for different scenarios, to see where they're effective, to see where they're not, and then to see what are the next steps that can optimize their impacts on the traffic flow. So in order to make this assessment, we have developed an impact assessment methodology, which involves basically two parts. The first part is the development of a cross-platform simulation tool, which helps us to actually emulate the formation of truck platoons, like the different functions which you have been hearing quite a lot, like the platoon support function and the platoon autonomous function. And then applying that simulation tool, it is across platform, so you can apply it for different microsimulators. And for our case, we have applied it to 2 different traffic simulators, which one of them is the very famous PTV VSIM, and also to an open source traffic simulator known as Simovia. And we apply it for a very specific highway corridor with an on-ramp or a merging bottleneck to see what are the effects in those locations. The other part is also testing, using the data from the open road testing to see, for a real highway corridor, to see what are the impacts on the traffic, on the surrounding traffic in terms of, specifically in terms of overtaking maneuvers and so on. So for the simulation, what we took is about a 6-kilometer long highway corridor with an on-ramp and at around 4 kilometers. We set the car speed at 120 kilometers per hour, like the maximum speed, and for trucks it is 80 kilometers per hour. And we develop a very realistic demand pattern, which is near to the peak hour conditions, to see the effects on congestion. And as the control variables, we take specifically 2 very important variables. One is the platoon function, where the first is the platoon autonomous function, where the gaps are really short between the trucks, and the platoon support function, where the trucks have relatively higher gaps. The other control variable is the share of trucks in the traffic stream. We consider a more homogeneous traffic stream with a really low share of trucks as the truck ratio low, and another really mixed traffic stream with a high share of trucks called as the high. So to test, we consider KPIs, or the key performance indicators, from 2 different perspectives. One is the road operator perspective, that is how this kind of multi-brand truck platoons affect the overall traffic performance in terms of road capacity, the queue discharge rate, and in terms of these 2, the congestion patterns. And here, what we see is the figures on the right are actually the heat maps of speed over distance and time, with distance plotted along y-axis and time along x-axis. And you can see at around 4 kilometers, we have the on-ramps, and we can see the formation of congestion. Well, for the low traffic or low truck shares, it is a more homogeneous traffic stream with high speeds, so we don't see too much congestion in the reference scenario. With the high share of trucks, we see more congestion forming, like the warmer colors indicate lower speeds. So once we incorporate the truck platoons, like the platoons, the multi-brand truck platoons, for the low truck share scenario, we see, okay, there is some negative impact on the speed and congestion patterns. But when the truck share is really high, then we see that the congestion is really reducing and the speeds are higher. So what we see is that the capacity is actually improved when we have a high share of trucks in the traffic stream, but there is not much impact on the queue discharge rate. So these kind of truck platoons are useful in improving the capacity and reducing or mitigating the congestion. But once the congestion has formed, it has no impact on the traffic stream. So the main conclusions are that it can increase road capacity for a merging bottleneck specifically with high truck shares. However, the increase in queue discharge rate is not significant, which means that it is effective in preventing or postponing traffic congestion, but it has less effect on once this traffic congestion has already formed. Also, we see that when the following gaps are larger, that is when the trucks are operating at support function level, it is easier for the merging vehicles to cut in and merge with the mainline traffic as compared to the autonomous function, which prevents them to merge with a high cut-in speed, and as a result, it affects the traffic stream performance. Now, we are also concerned with how it impacts the road users. That is, we are concerned with how the travel speeds and delays are affected for different vehicle types, how many number of stops are made by these vehicles, and how many hard brakings are made for both car and truck users. So what we see is, with the autonomous function, as you saw before, that there is a slight reduction in the speeds, but with the support function, and for high truck shares, we have a slight increase or quite a good increase in the speed function. The other thing is, which is very important in terms of safety, is that when the platoons are operating for a high truck share, we see a significant reduction, about 16% reduction in hard brakings among the cars, which is a direct indicator of safety and flow stability. So this simulation API, as I was talking, it is for the truck platoons. It is available, and you can actually use it. You can go through the documentation, and you can apply it for for other scenarios if you want. And specifically, we have developed it for Visim and Simuvia, as we told. But if you're interested, we can actually do it for other traffic simulation platforms as well. Now coming to the open road testing. So what kind of sensors did we use? We used a drone footage to see, okay, both the longitudinal behavior and the lateral behavior from two different angles. We also took a LiDAR sensor to see how microscopic aspects, like how the different vehicles are overtaking or behaving near the truck platoons. So the main observations, as we did some open road testing in some highway corridors near Barcelona, we saw that under the free flow conditions, because in simulation we tested more on the peak hour part, like where the traffic flow is quite near capacity, but under free flow conditions, which we observed from the open road testing, is that more overtakings are done by cars, which are on the same lane, and but fewer trucks are actually performing the overtaking, like only about 40% trucks are overtaking. And from the maneuver, we can see that, okay, the car is initially following the truck platoon, but then it increases its speed and changes lane. And then once it completes the overtaking maneuver, it comes down to a speed which is about 10 kilometers higher than the platoon speed, which was 70 kilometers per hour in the open road testing. So one of the major conclusions is that, okay, under free-flowing conditions, if the platoon speed can be increased from 70 km per hour to 80 km per hour, we may have fewer overtakings even by the cars as well under free-flow conditions. So what are the key insights to the road operators? We see that there is some improvements in traffic flow and traffic efficiency, but it is under very specific conditions, like when the truck share is high, and also when we are approaching an on-ramp, when the platoon function has to be accommodating for the on-ramp vehicles to merge with the main traffic stream. So first of all, initially, the deployment of these kind of multi-brand truck platoons can be done near major freight corridors. Like, for example, one example that comes on the top of my mind is the A63 highway, which is one of the main highways connecting from Spain to France and the other countries on the east. And also, in mixed traffic situations, we can apply some kind of traffic management measures, such as coordination near merging, like some kind of on-ramp metering through V2I technologies, to make the other vehicles aware of the truck platoons approaching and to have a more smoother merging. Or we can have some kind of other V2I technologies to change the platoon functions, like it can change from autonomous function to support function near the on-ramps to allow for the vehicles to merge in smoothly. So that are some things which you can explore, which we can explore in the future to have a more optimal, more optimized effect of truck platoons on the traffic performance, especially when the truck share is low. So thank you. And
thank you, Kinjal.
Yeah.
for presenting this really interesting finds. I wanted to touch upon one thing that you, I think, briefly mentioned about the API that you used for your simulations. Is that something that is also something that other parties can use?
Yes, actually, this kind of API, as I showed in my presentation, you have the link to the API. You can actually go through documentation. You can understand how it works. There are some examples, and for now, you can use it for Visim and Simovia specifically. But if someone else, some researchers or someone else, is interested in applying it for other different traffic microsimulation tools, we are open to work with them and to find, to solve the issues and apply it for different scenarios. So everyone is welcome to use it. Thank you.
Thank you so much. Great offer at the end. Thank you, Kinjal.
Thank you.
Then on to something that has already been mentioned, I think, several times throughout the day, and that is the human factor. So the other road users. We've been talking technology and standardization and regulation and all that very exciting stuff, but what about the people that are being confronted with a truck platoon? I'm really happy that I have here with me Christophe Jallet. And he is a researcher of the cognitive sciences and has been studying this particular element of truck platooning. And he is also from the same university, Gustave Eiffel, like Kinjal is. So please enlighten us about the sort of psychological effects of truck platooning.
Yeah, I will try to. Thank you, Karin. So I'll present to you now a study that we have developed inside this project about the impact of the platoon on different road users. This study was trying to tackle different traffic safety issues. So to do so, the objective of the study was to evaluate the interaction between the platoon and different road users. And we assessed the emotional and attentional state of the road users and also their behavior. We used a simulator to do this on different use cases. So for the use cases, we had a 3-truck platoon or a 7-truck platoon. We also measured different inter-vehicle distance, 0.8 seconds and 1.5 seconds. Different driving situation, overtakings, ingress, egress on the highway, and we manipulated also the traffic flow, low or high traffic flow. Today, I just focus on 2 driving situations, only the ingress situation and the egress situation. And what we assumed inside this project, inside this study, is that when people encounter the 7-truck platoon, we thought that this interaction will lead to a higher negative impact about the emotional and attentional part. And we assume also that the short inter-vehicle distance, 0.8 seconds, could lead to no cut-in at all. To do this experiment, 51 people were involved in this study, and we divided the participants into 2 groups. One part was encounter a 3-truck platoon, and the other part, the 7-truck platoon. We assessed different measures, subjective ones, with the emotional state. For example, we assessed fear, anger, and anxiety levels. We also measured the attentional level, like alertness. And for the behavioral measurement, we assessed speed and also the position of the participant when they encounter the platoon. What we categorize this interaction into 3 categories: ahead, cut-in, and behind. By ahead, we mean that when the participant drives on the same lane on the platoon, he was driving in front of the first truck of the platoon. Cut-in means that he was driving between trucks, and behind means that he was at the back of the last truck. Concerning the subjective measures and for the 3 trucks platoon, what we observe is that for the high traffic conditions on the short inter-vehicle distance, 0.8 seconds, we observe that most of the people felt more angry when they encounter these platoon conditions. And for the 7 truck platoon, what is very interesting to know is that for the 0.8 seconds on the 7 truck platoon, it was one of the critical situations. People felt more fear, more anxiety, more angry, and more alertness. And for the 1.5 seconds, most of the people, whatever the traffic flow, felt more angry about this interaction. For the behavioral measures during the egress, what we observed is that whatever the traffic flow, whatever the number of trucks involved in the platoon, most of the participants wait behind the platoon to exit the highway. For the ingress now situation, what we observed for the mean speed, we observed that when people decided to use the insertion lane to overtake the platoon and go ahead, this situation lead to a higher speed. So it's a logical result. But we did not observe any statistical differences between all the conditions concerning the mean speed. But what is important to know is that this insertion speed was lower than the speed limit, which in France is 80 kilometers per hour. So this is maybe one critical situation. Still concerning the ingress situation, this is maybe the most important result that we observe in this study. What we observe is that for the 7 truck platoon, whatever the inter-vehicle distance, 0.8 or 1.5 seconds, most of the participants decided to cut in the platoon and dissolve the platoon. So this is very important to know that this 7 truck platoon could lead to a cut-in situation. Concerning the time spent now on the right lane after the insertion, we have observed a traffic effect which is logical, meaning that when the traffic is high, you spend more time on the same lane than the platoon, because you have to decide if you can overtake or not the platoon. But one result was very surprising, and we do not have any scientific response to give to this result, is that when the traffic was low, meaning that there is no traffic on the left lane, when people encounter the 7 truck platoon, they spent around 20 seconds behind the platoon. So what the interpretation that we gave to this result is that it's like a relief situation. So I encounter a 7 truck platoon, yeah, I just stay, be calm, and then I decide to overtake. So it's surprising, but we do not have any other explanation about this result. For the to sum up the result of this study, concerning the 3 trucks platoon, what we observe is that this platoon, in particular in high traffic situation, could lead to make people angrier. And for the 7 truck platoon, whatever the traffic condition, we observe the same kind of results. People could feel more angry when they encounter this platoon. And for the 0.8 second inter-vehicle distance, this situation, this condition, platoon condition, could lead to be more angry, anxiety, and angry. Concerning the behavioral measurements, what is important to know, as I already said, is that whatever the number of trucks involved in the platoon, the insertion speed was below the French speed limit, so below 80 kilometers. For the 3 trucks platoon, for when the inter-vehicle distance was fixed at 0.8 seconds, people decided to wait behind the platoon and do the insertion behind the platoon. And when the inter-vehicle distance was fixed at 1.5, they decided to cut in the 3 trucks platoon. And for the 7 truck platoon, whatever the inter-vehicle distance, it was mostly always a cut-in behavior that we observed. So to conclude, we did not observe any accident with these different interactions between platoon and road users, but it was more due to the platooning functions that we have simulated. The 7 truck platoon could induce negative emotions, and the ingress situation could be the most critical. We observed a lot of cut-ins on the low insertion speed. So it means that there is a high probability of dissolution of the platoon during ingress situations. Thank you.
Thank you so much, Christoph. I would like to invite you now to come and sit with me at the table to really dive into this topic a little bit further.
Yeah.
Because I think you have disseminated a lot of new finds, done a lot of new research. And one of the key questions that comes up into my mind is, we've seen the simulators in your presentation, but what would happen if you would be testing this in real life? So actually on the open road with real, well, the people are real, of course, that were in the simulator, but with actual road users.
Yeah, I think normally we should observe the same kind of results, but driving the interaction in real conditions, people could have the impression that their life could be in danger. It's not the same thing. Driving on a simulator, it's a comfortable situation. Driving during real condition on a real highway with your car, it's not the same thing. So maybe people could be more anxious that they can feel during the simulator study.
Yeah.
But we have to test this in real condition, and I really hope that it will be possible soon. But yeah.
Yeah. So your hypothesis is that maybe the fear of death will actually
enhance the different negative emotions. Maybe it's possible.
Yes, but a hypothesis, of course.
It's an hypothesis, yeah.
And do you know? I think Ms. Ptasinska referred to it a little bit. That there is also a lot of research going on outside of Europe. Do you know of any situations where they're actually testing in real life?
Yeah, inside the ENSEMBLE project, we had a training program with the US, with the Federal Highway Administration, and I know that they tested on simulator, but also under real conditions, the interaction between platoon and road users. And they are more focused on how to build some countermeasures, how to warn people that they encounter a platoon. So this is a kind of
so
research.
They're adding other variables to.
And what they observed is this quite the same result that we observed. So negative emotion linked to this interaction, anxiety and fear.
Yeah. Yeah.
But they use some countermeasures, panel sign mounted on the back on the truck or roadsides.
Sorry, what was the countermeasures? What was the countermeasure
some
they used?
Signs.
Signage on the trucks.
Mounted on the trucks, warning people that this is a platoon.
Yeah.
So be careful or not, I don't know, but just to warn people that they encounter a platoon and not just trucks driving together. So automated trucks.
Okay, yeah. So and then they're going to see whether or not that's going to influence the behavior and the emotional state.
Yeah, emotional and behavioral state. Yeah.
And that makes me wonder, are people, even if they're warned, are they familiar with what a truck platoon is? Because it might also, the unfamiliarity might cause the anxiety, maybe.
Yeah, this is one question that raised from the study, is that they ask people, do you know that it's a platoon with automated trucks or not? And most of the people did not recognize that the trucks are driving automatically. The trucks are autonomous.
Yeah.
And they ask them, is platoon the correct word to use to describe this kind of behavior?
To make sure they even understand what it is.
70% of the people responded that no, platoon is not maybe the correct word to use, but we prefer convoy. So maybe a convoy is more appropriate to describe the kind of truck behavior.
Yeah.
Yeah.
So it's even down to semantics then, whether or not people will understand what they're encountering.
Yeah.
That is interesting.
And for our study, what we planned at the beginning of the ENSEMBLE project is to test some countermeasures, like using, as I said, road sign or panel sign mounted on the truck to warn people. But due to the COVID situation, we had to postpone the simulator study that I just presented, and we did not have the time to perform the second study. So as a next step, I think that the countermeasures should be tested just to...
yeah. And then you're saying paneling on a truck or road signage. Are there any other countermeasures that you could test?
Just testing these two kind of countermeasures, it's
already a big thing.
It's a big thing
Sorry,
to test.
I don't want to add to your
but
workload.
just to begin, maybe just beginning with this kind of signs on the road, mounted on the road or mounted on the truck, it could be sufficient just as a first step. But,
yeah. Okay. let's start with that. And I think I mentioned just a few minutes ago that there's a lot of new things coming out of your research. What are some of the highlights or the new things that people should definitely remember?
I think that they could remember that the platoon has some functions that can lead to safety. So platoon could be safe. So this is one thing. But another thing to have in mind is that the insertion situation is the most critical about safety because of the low insertion speed, because of the number of cut-in, and because it will lead at the end at high probability of dissolution of the platoon. Mm-hmm. So it will have an impact on the economical part of the platoon. Yeah. So this is maybe the important result that you should have in mind at the end. Yeah.
And then maybe building on that, who should have this in mind? I mean, who should take this up or pick up on this research that you've done and think, okay, we're going to take different measures or do something with infrastructure. So what is the takeaway that you hope which stakeholder will take?
Maybe the stakeholders, but also...
But they call you. What do you say?
The stakeholders, the OEMs.
Call me.
Yeah, maybe they should have this in mind, but also all the citizens that we are developing something safe. We are trying to have this thing safe, and I think that maybe we should develop this kind of question to develop the acceptance of this truck platooning in the future. So,
yeah. And you're a cognitive scientist, so I was thinking about this. Will a 7-truck platoon, will that ever feel safe to a human with sort of a reptilian brain going, that is big?
I don't know. It's the reason why we have to test all these driving conditions in real condition, in real traffic. Yeah. I don't know. Maybe when you have to insert on the highway and you see a wall of trucks, a long wall of trucks. Yeah, I don't know. It's difficult to answer. Concerning the result that we observed, I should say that maybe people will be more anxious and stressed.
Yeah.
But I don't know, we have to test this. So it's a good point and a good question and a lot of job to do in the future.
Yes. Well, thank you so much, Christophe.
Thank you.
For enlightening us a little bit further.
Okay, thank you, Karin.
Then it's break time. At a normal conference, you'd probably grab a sandwich and a drink and start talking to new people, start networking. Since this is a live stream, that's going to be slightly more difficult, but I would really like to invite you to please send us your questions or topics or thoughts that you'd like to raise. And maybe you could even reach out to a colleague or somebody sitting next to you to discuss some of the topics that came across the agenda this morning. I would really invite you to. This afternoon, after dealing with all the impacts this morning, we'll go into the future of truck platooning. So there's a lot of exciting stuff ahead. About the business case, it was already mentioned. We're also, I think that was already mentioned several times, we have the key stakeholders around the table in a panel discussion. So lots to look forward to and hope to see you back at 1:45. Thank you. Welcome back. I hope you all had a really interesting lunch break, and we will be talking this afternoon about the potential of truck platooning. And I think it's been mentioned several times during the morning by different speakers. The business case, the big ticket item, is there a business case? And with me is François Krombe. He is a freight transport economist at the Université de Gustave Eiffel, and he will bring us up to speed whether or not and under which circumstances there is a business case for truck platooning. François.
Thank you. So, my presentation will be about, as introduced, one of the dimensions that was analyzed in terms of the impacts of platooning. More specifically, we looked at three questions. The first one is about the core value of multi-brand platooning. The second one is about what can we expect in terms of market uptake regarding multi-brand platooning. And the third one is about the external impacts of multi-brand platooning. So, the basic situation is that we're talking about introducing a new technology inside a complicated ecosystem with many stakeholders. So the first thing which everyone should have in mind when looking at the question of the business case of platooning is where is the core value creation? And that may seem obvious, but it's really a necessary step in order to identify where value is created and where it will circulate inside the ecosystem in order to understand what will be the position, the predictable, reasonable position of stakeholders regarding this new technology. The core value of platooning, the moment where platooning actually brings value inside the system is obviously when trucks are inside a platoon, when they have formed a platoon. And these savings, we already talked about that during the day, can come from many sources. The main one, the one which was looked at with the most amount of detail inside the ENSEMBLE project, is the fuel savings that can be realized thanks to the formation of truck platoons. But there could be other causes of cost savings in more futuristic scenarios, for example, savings in terms of workforce costs, which is another very important cost position for the production of freight transportation. So that's the benefit side of the story. And then there is the cost side of the story. And the cost side of the story is actually in two parts. The first one, which is very important to have in mind, is the coordination cost. So what do we mean like that? The thing is, if you want to put trucks inside the platoon, you will have to coordinate the movement of two vehicles that initially do not necessarily have the same starting points, destination points, and schedules and itineraries. And this coordination, which is necessary, which means that two trajectories which are initially different will have to be aligned so that the formation of the platoon can actually be realized. This will incur costs. This can incur direct costs for transport, for carriers, for freight carriers. This can incur indirect costs in terms of worsened level of service for shippers. And these costs, this is something that the stakeholders will take into account when deciding whether to use the technology or not. And then there is a second cost category, which is the specific investment that carriers will decide to make or not when purchasing trucks, whether they want these vehicles to be platoon-enabled. And they will make this higher level decision, this investment decision, based on what they expect that they will realize in terms of benefits if they opt in this new technology, and based on what they think the other stakeholders will do. And this strategic interdependency is something that we looked at, and that is very important to have in mind when trying to have a reasonable idea, a quantitative idea of what the uptake of platooning will be. The ecosystem, as I said during my introduction, is rich and a bit complicated. You've got carriers at the core of the system, freight transportation. That's what they produce. And they produce that for shippers. Shippers are all the firms that manage supply chain in a way that where commodities can be made available to us, to customers. And OEMs, on the other end of the value chain, provide vehicles to carriers. You also have another host of stakeholders which are directly concerned by platooning, such as insurance companies, which look at the safety questions. You've got the platooning service providers, which are societies which will be necessary for the process of platooning to actually work. You've got regulators and policymakers that will have to modify the rules or make new rules regarding platooning. And you've got infrastructure managers who are obviously interested about what's going on with platooning and what they are going to allow on their networks. What's going on inside this complex ecosystem? Actually, the value chain of platooning is not that complicated. You've got OEMs providing a new technology. You've got carriers who will have to decide to determine whether it's valuable, profitable for them to opt in this technology. You've got shippers that will maybe face a modification in terms of prices and the modifications in terms of level of service. And this is something that has to be accounted for. And then there is this arrow shaped as a circle, which is around this label of club effect, which in fact represents the interdependency between the decision of the carriers. Platooning is based on matching vehicles with different trajectories. It's costly to do so, but it's less costly if there are many, many opportunities for matching. If you've got a lot of candidates for matching, you will find one who's not too far from what you want his trajectory to be so that you can form a platoon with him. In other words, the more people opt in platooning, the higher the value of platooning will be. And this is typically what we call a club effect. The value of going in the club is higher if there are many members in that club. Regarding market uptake, as I said earlier, you've got these two layers of decisions to look at. The first one is the platoon formation decision, which is an economic decision, and the second one is the vehicle equipment decision, which is also an economic decision. And the first one is actually conditional to the second one. So this is something that should be kept in mind as the main structural characteristics of this market. We looked at, in terms of quantification of the market uptake, two different scenarios. The first one corresponds to the platooning support function, where we assume that the leader vehicle will only have 0% of fuel savings. In other words, the operating costs do not change, and the follower vehicles will have a reduced fuel savings of about 5%. And the second scenario that we looked at is the platooning autonomous function, where we assumed that the following vehicles in the platoons will have a reduction of fuel consumption of 10%. And the conclusions are actually quite straightforward. In the first case, in the case of the platooning support function, with reasonable numerical assumptions regarding all the costs that we accounted for in our model, there is no business case for the platooning support function. But by contrast, there is actually, with reasonable assumptions, a business case for the platooning autonomous function due to the higher savings. To get now into a bit more detail about these results, the thing that we are able to produce are how the market uptake will move in time. So in this kind of graphs that you can see here, you've got on the x-axis the time dimensions. So you've got years going by, and then on the y-axis, market shares that go from the 0% to 100%. And in this case, which is a median scenario where we take median assumptions for many parameters, you can see that, for example, if the initial investment cost that is specific to a platoon-enabled vehicle, there will be a market uptake, but it will be slow. It will take up slowly. Actually, in this case, you will only see a significant market uptake starting at year 8 after the time 0 when the technology is made available. Obviously, this is sensitive to a lot of parameters. For example, if you assume that the cost of the equipment goes down to 2,000 euros instead of 3,000 euros, then market uptake will happen, and it will happen much more quickly. As you can see from this example, the sensitivity of market uptake to the initial parameters can be very high in this kind of model. And this can be explained as part of what I explained earlier in terms of club effect. You've got a positive reinforcement loop that makes the result of this type of model typically very sensitive to the assumptions. In this median case, we typically have over the whole fleet, a 5% fuel savings on average and 1% financial savings. So that gives an idea of the economic and financial impacts of platooning for carriers. Last slide before my conclusions. You can see here one of the many sensitivity tests that we simulated. In this one, which is very favorable to platooning, instead of assuming that fuel prices remain stable over time, we assume that they increase steadily. And of course, this is much more favorable to platooning because the financial value of reducing fuel consumption is much better for platooning. And you've got more curves on this graph because there are more cases with a higher cost of the technology where market uptake remains starting and going upwards to 100%. So final conclusions. The benefits of platooning depend on how often a truck is in a platoon. And this is something which is quite important because in real life, there will probably be market segments where some of the trucks will be very, very often in positions where they will be in platoons, and some other trucks which are more dedicated, for example, to regional transportation, will be much less often on the kind of networks where you would expect platooning to happen, spontaneously. There is this notion of coordination cost that I talked several times about and which is very important to have in mind in terms of the business case of platooning. And I remind these conclusions that with the platooning support function, we could not find a situation where we had a business case, but with the platooning autonomous function, there are reasonable assumptions where we have a business case for platooning. Thank you for your attention.
Thank you very much, Francois. You also touched upon something that has been discussed earlier between the support function and autonomous function and the differences in the business case. But are there maybe other variables that could be boosting the business case over time?
Yes. This question of club effect, as I explained earlier, makes it it's a very important characteristic of this market. The fact that one carrier will only opt in the market if they are more or less sure that other carriers will also go in the market. If they are alone, then the value will be zero. And this is a strong source of uncertainty and probably something where either an action from the OEMs or from policymakers to kickstart the market by anyway providing vehicles to big customers or subsidizing the technology at the beginning will help the market start and help the consensus of the market to align with the fact that everybody will get in and everybody will be sure that everybody else will get in, and then this will have value for me.
Perfect. So we need to kickstart the club, basically.
Exactly, yeah.
Thank you so much for your explanation. Thanks, Francois.
Thank you.
Kickstart the club. It's getting more interesting by the minute. We briefly touched upon the cost of coordination, and that is also one of the questions that we're trying to answer this afternoon. How difficult is it to match vehicles into a platoon occurrence? And we have somebody here who can tell us all about it. It's Ernst Jan van Ark. He's a research scientist analyst at TNO. Sorry, I'm making you into something that you're actually not. You're a research scientist, smart mobility at TNO. Let me be very thorough here. Take us into the wonderful world of platoon occurrence and matching, please.
Thank you very much, Karin, for your introduction. As already briefly introduced, as part of my presentation, I will look at the topic of platoon occurrence and matching. First of all, I will start off my presentation with relating the concept to the other presentations that you might have seen today. Subsequently, I'll look at the topic of matching and platoon coordination itself. And subsequently, I will discuss multiple applications that we have developed as part of the ENSEMBLE project. First, relating the topic of platoon coordination in relation to all the other presentations that you might have seen today. If you remember correctly, Delia Willemsen touched upon the more technical aspects from the real-life demonstrations in Madrid. And afterwards, you've seen multiple presentations concerning the impacts of platooning. However, only having the technology does not directly mean that you can attain the impacts that have been discussed this morning. There's basically one vital step in the middle where you apply the technology in practice and you ultimately integrated in the logistical operation to attain the benefits that you can achieve. And that's exactly the topic that I will cover today. The concept of platoon coordination and matching. Basically, if you look from a helicopter view, you can derive 3 different layers of abstraction that are part of platoon matching. On the most lower level, you have the vehicle and platoon level that basically defines the inter-vehicle distances and really controls the individual vehicles that are part of a platoon. Having vehicles that are platooning capable needs some functionality to bring the vehicles together. So where are our platoons being formed and how are they matched together? Which is part of the second layer in the middle of the picture on the screen. The upper layer is much more the logistical operations as part of fleet of logistic service providers. So having a freight schedule and deploying their fleet as part of that operation as effectively as possible. Let's have a look at the data elements that are part of these 3 layers, because basically that can make this layering very much more tangible. So from the logistics level, you basically have your origins and destinations and time constraints as part of your logistical operation. That's subsequently processed as part of the vehicle and platoon coordination layer to match candidates, a route that a platoon can follow, and also the geolocations on which that platoon is being formed and dissolved. However, you also need to know the status of the vehicles to understand whether a vehicle is still able to make a platoon, or if something else has happened which might hamper the platoon to be formed. And lastly, as part of the logistic service provider, you also want to know where platoons have been formed, for example, to see how you can share the costs and the benefits of platoon matchmaking. As part of ENSEMBLE, we've developed a proof of concept for platoon matchmaking that basically studies when, where, and how platoons can be formed, and to see the different advantages and disadvantages of platooning, and to determine how does scaling up work. How many vehicles do you actually need to have to be able to make it work? And as part of this research, we tried to stick as close to the realistic world as possible by using realistic real-life data and statistics. But how does this platoon matching work in practice? Just imagine 2 vehicles on a certain trajectory that are driving behind each other. And you can depict those vehicles in a time-space diagram as depicted on the right figure. If these vehicles are following each other, you can see as part of the black lines that they do not meet each other. In this case, the leading vehicle should slow down, as depicted in the red line, to meet the following vehicle and to platoon the remaining part of the trajectory. However, slowing down and really taking some extra time takes extra time and effort, which ultimately also results in a cost that you ultimately have to cover by means of the benefits of a platoon. So, in order for trucks to platoon, you need to make arrangements on where they are made, at which speeds they are going to travel, and in which order they are going to be driving as a platoon. There are various concepts that you can apply to make this happen. You can basically look at a schedule, so the day before, based on your logistics schedule, already connect different vehicles together that can platoon. But you can also do this on an ad hoc basis. Just think about a virtual truck Tinder application that combines trucks together. You make this platoon, you you really depend on the chance of finding a platoon candidate, which is basically very affected by the freight demand on a certain route, and also on how many vehicles of that freight transport are ultimately equipped to be able to platoon, which represents the penetration rate of the technology. As part of ENSEMBLE, we developed 2 parallel methodologies to demonstrate this matching in practice. Research from the KTH, which is a Swedish research institute, developed the so-called dynamic programming approach, which basically assumes aggregated historic shipping data and aims to match vehicles based on that, which also included explicitly the difference between single fleet and multi-fleet platooning. At TNO, parallel to that, we developed a data-driven simulation study, which basically uses real-life logistical data that's derived from DAF as an OEM that partnered in this effort. First of all, let's have a look at the methodology of this dynamic programming approach that was developed in Sweden. The colleagues derived a road network that included 105 major logistical hubs. And basically, they assigned a fleet of 5,000 vehicles to this network that started a trip every hour. And based on the trips between the different OD pairs, they were virtually able to show driving trucks and to match those together to platoons. And as part of this research, they calculated the distance that they were able to platoon in various scenarios. There are 2 results figures that I would like to emphasize as part of this presentation. And that's basically the difference between single fleet coordination and multi-fleet coordination. Each of these 5,000 vehicles was assigned to a fleet based on statistical data. And basically, what we try to do is to differentiate between the effects when fleets are able to match on its own, so only vehicles within the fleets were matched, or when you allow multi-fleet collaboration, so basically vehicles between different fleets were able to platoon. And basically what it shows us is a big difference between both methodologies. If you look at the single fleet coordination, the chance for a vehicle to ultimately find a match candidate is very much smaller. Of the 5,000 vehicles in this case, almost 4,500 vehicles were not able to find a match candidate and were driving solo. However, if we look at the results of the multi-fleet platooning coordination, we see almost an inverse figure, where 800 vehicles of the 5,000 vehicles were not able to platoon, but 4,200 vehicles were able to platoon. And a large share of these vehicles were also able to platoon the full trajectory, so the full trip. Then looking at the data-driven simulation that we've done. As mentioned earlier, this research included a data set that we received from the DAF Connect that basically consisted of a fleet of about 40,000 vehicles that drove in Europe and that provided a data point every 5 minutes. And what we've done is we really enriched this data by means of an extensive data processing pipeline to attain one location per 5 seconds for each vehicle. And based on that information, we derived which vehicles were close enough together to platoon in practice. So this is basically really focused on the real-life logistical operation as we see today. And the simulation mainly focused on the Netherlands because due to mathematical complexity and also the fact that we had different data sources that we were able to connect to it. often result figures and videos say more than 1,000 words. I will shortly start a video that basically shows the matches that have been made in the Rotterdam area. And as part of the video, you will see individual vehicles colored by red circles and platooning vehicles by means of blue crosses. And basically, what you see is that already in real-life situations, platoons can be formed and can be matched. So for me, this figure makes it really tangible how vehicles actually drive around and whether vehicles were close enough together to be able to be considered as platoons. Looking at the results figures. As part of our analysis, we basically assumed different fleet sizes. And we did the analysis across all those fleets. And basically what this figure shows is, depending on the number of vehicles that we include, how much distance can these vehicles drive as part of platoon. And what you clearly see in this figure is that there's an increasing effect. So if you add additional vehicles, those vehicles themselves are able to platoon, but also they are able to improve the match potential of already existing vehicles in your data set. So you see an exponential effect. The result that you see here relies on an inter-vehicle distance of 1,000 meters. As part of the analysis, we also focused on lower inter-vehicle distances to see how that affects the ultimate match potential. In the four figures here, you see when you lower the required inter-vehicle distance, the match potential goes down, but we still see the exponential effect and the increasing effect across when we increase the vehicle fleet. On the right of this figure, you see a representation of the Netherlands, where the vehicles as part of the simulation actually drive around. So this is a heat map, how often vehicles or platoon, how often platoons pass a certain point. And what you clearly see is that the main logistical hubs in the Netherlands, for example, Rotterdam, Eindhoven and Utrecht, are clearly represented and can be clearly seen. You can also see that the main freight corridors in the Netherlands are also represented very well, such as the road from Rotterdam to Germany. Then the conclusions of my presentation. Platoon coordination can be considered as a linking pin between having the technology available, knowing the different impacts, and how can you integrate this into the real-life logistical operation. And especially this platoon matching is important in the early stage of deployment, given that at that point still few vehicles are available and platoon capable. You should really find a way of how to bring those vehicles together. Both simulations clearly show that there is potential for truck platooning to be adopted, even without making very big changes in the daily logistical operation. However, the cooperation between the fleets is crucial, so it's important to look over one's organizational boundaries. Then some reflections on the results. We've seen that adoption is possible, but still to be able to really uptake the technology, it requires a positive business case for the logistical service providers to ultimately apply the technology. And this is also what our colleague Francois Combe just mentioned in the presentation earlier. However, based on this data and real-life data, we have a better understanding about how the potential uptake can look like and how we can apply this technology, which we also can apply to various stakeholders. For example, to show for logistical service operator, how does my operation fit into the operations of others, but also from a road operator perspective. So where do platoons ultimately drive, and how can we apply that to our operation? The results from this might provide future guidance in the current conversations about the potential uptake. For example, discussions can happen whether to provide platooning in nighttime or between specific logistical hubs. And based on the simulation that we've developed, we might be able to simulate or to see how that happens. And lastly, the link with real-life data makes the technology more tangible. Ultimately, to see the different vehicles driving around, for me, really helped to understand what might be the future options. Thank you for your attention. This was my presentation.
Thank you, Ernst-Jan. Can I invite you over to the table, please? Because I was really intrigued by your final reflections. And you've shared some of the simulation and the modeling that you've done. And maybe we can explore a little bit together how that could assist the uptake that you were referring to.
Yes.
So maybe starting with the both simulation models that you mentioned, what are the main strengths of those two different types of simulation models?
Well, I personally think that both models and both simulations can really complement each other. In a way, the analysis that the KTH did really focused on the statistical data and for example, applied specific circumstances, for example, free flow traffic. Mm-hmm. So that allows the variables to be quite static. The data-driven analysis that we applied as part of the data-driven analysis really included real-life data and also all the dynamic aspects. So, for example, traffic jams or incidents occurring.
Yeah.
So, for example, for the KTH, it might be possible to determine the optimization factors that you have. For example, by changing different trips earlier or later.
Yeah.
Which for the data-driven approach is more difficult because then you see you get a cascading effect of vehicles that might drive through congestion, for example. So both methodologies are really complementary to each other, and I think that's the main strength of these both simulations.
Yeah, and you were also, I think, already mentioning in your presentation about the road operators or the logistics providers. Now that you have this underneath your fingertips almost, how could they use it, or how could you use it to help them understand what the potential is, and hence also the uptake of the truck platooning?
Well, as I mentioned, for logistical service providers, it can make, or the simulation results can make it more tangible to see whether their region of operation connects with also the routes of or the trajectories that we've seen as part of the analysis to be really busy in terms of potential truck platooning.
Yeah, so what are you saying? Let's assume I'm a logistics provider. I know where, of course, my fleet is going, or what my trip data is. Then what you're saying is they can actually compare it to the data that you've got and see where the combinations are potentially to be made.
Yeah, exactly. So, for example, we saw the Rotterdam area to be quite. There, a lot of platoons became apparent, and also on the main freight corridors in the Netherlands. So it as a service provider, it makes it more tangible for you. How does my logistical operation ultimately also fit in the ones of the others, especially because this multi-fleet collaboration is one of the most important factors, as I mentioned.
Yeah, and it's something different from the multi-brand. I mean, this is a distinction, right?
Yeah, both. I think, in a way, the multi-brand is a pre-requirement to be able to multi-fleet.
To go multi-fleet, yeah.
Because ultimately, also, well, there are fleets that are mono-brand, or that only apply one brand, but especially the combination of both can be strengthening.
Yeah, I can understand that. And I think I mentioned it earlier, I have a logistics background, and then I think, multi-fleet? Oh, wow, okay, so that means cooperation, collaboration. Might not be necessarily in the DNA of the business. So taking that into consideration, what are you also mentioned the road operators, right? So what would be the value for them to look into these models?
Well, one of the questions, for example, that also was covered in an earlier presentation is what is the effect on your infrastructure? Basically, what can we expect at bridges and tunnels? Looking at the simulation, where do platoons occur, can also help in mapping for them which infrastructure is applicable and where should we first focus on, or perhaps to find out what are the first corridors where we would like to apply such a demonstration or a test, for example.
Yeah, makes sense. Well, I hope they're all watching and thinking, okay, that sounds super interesting. When can I start, or when can I start using it? And maybe extrapolating that into dreaming big. So what would be sort of the ultimate opportunity if you had all the data available in your modeling?
Well, I think we've seen a lot of different impacts. We've also seen a little some constraints, for example, the business case. I think it would be very interesting to see how everything also ultimately comes together and can be integrated even more.
And if you're talking about integrated even more, what is it you're talking about?
Well, for example, the simulations assumed some cost and benefit to be able to determine whether there was an added value for the platoon to be made.
Yeah.
For example, at the simulation where I was involved, you ultimately have to make a decision: how long do you want to delay this vehicle to be able to be matched to a platoon?
Yeah.
If we know, for example, much better the potential in fuel efficiency, that can also be integrated again to see whether we can make the models even more representative as they are right now. And I think also in a way, the methodology that we applied here can also be applied to other fields. I've worked also together with some other colleagues that were working more on the logistical department. For example, having the data that we applied here, given all the constraints with GDPR and confidentiality,
yeah,
it's worthwhile to see how these methodologies can be applied wider.
And wider, you're thinking of?
Well, platooning is one use case that we applied it to, but you could also think about different drivetrains or different engine types, for example, electric. You can basically apply the same methodology as we did in a data-driven analysis to see what kind of percentage of the fleet might be worthwhile to shift towards other types of energy.
Yeah. Okay, so there is still a lot of ground that can be covered. Are you willing to take a question from the audience? Because I think I don't think if it just came in, but I have one for you. It's from Bob Dodemond from the Port of Rotterdam, and he's saying platooning on the fly is, from a logistical perspective, the most attractive. Do you think that this is a realistic scenario for the future development and deployment?
Well, yes, on the fly is perhaps your first step, because that's basically, as I mentioned already, the truck Tinder application can be your first application.
The truck Tinder, that is sort of the is this copyrighted phrase, or is it just something that TNO people say to each other?
Well, I think it's also mentioned already broader.
You can't coin it anymore. Okay, sorry, continue.
But what you see in that regard is on the fly ad hoc really looks at which vehicles are around me. But on the other hand, that allows less room for optimizations in a way.
Yeah.
Perhaps not the first one, or not your truck next to you is your first potential, but looking somewhat broader can even provide you a much bigger benefit. So it's a first step, but especially also towards automation. I think some more optimization levels might also be very worthwhile to consider.
Okay.
But can you repeat or?
I think well, I have to sort of think what Bob is thinking at this point in time when he was writing this particular question, but I think he's asking, is it a realistic scenario?
Well, it is a realistic scenario. But you really also need to look at ultimately the business case. When are you going to actually platoon yes or no, and how can you uptake that in the vehicles? As I mentioned, the topics that also Francois made there are quite relevant in combination with the ultimate benefits that you see from the platooning itself.
Yeah, makes sense. Well, and if it's not the right answer for Bob, I'm sure he knows how to find you, and he can ask you the question again. Thank you so much, Ernst-Jan, for clarifying this, and also for tying your presentation into some of the other presentations that were given today. I think it is painting a clear overall picture. Thanks.
Thank you. You're welcome.
Now, it has been announced, I think in the morning also, we have with us Carlos Lujan, who is a Senior Manager of Homologation of IDIADA. And he will be telling us more about the research that has gone into the regulatory framework. The missing piece, the thing that we are still need to address in this particular day, and a step towards truck platooning. So Carlos, can you please tell us what you have done?
Okay, thank you, Karen, for your very kind introduction. First thing I would like to mention is that I am here representing an amazing team of experts that has been supporting with this task the preparation of a proposal on future regulations in order to be able to deploy platooning technology. Or, in other words, how are we moving from the idea, the initial idea that we had when we started discussing about this project, to the reality. And the reality is the actual deployment of the vehicles on the road. Normally, when we are talking about innovation, when we are talking about research, we are focused in technology, we are focused in very innovative solutions, but we don't focus in an important link with the reality. And here, the link with the reality is the regulation for the type approval. Because if we don't have a suitable regulatory framework, those vehicles cannot be considered vehicles. They may be 8 tons or 10 tons of steel, of plastic, of semiconductors, but until they don't get the registration plate, they cannot be considered vehicles. So in this presentation, I will define, or I will explain about the activities that we did in order to find this link with the reality. And this link with the reality shall also be linked with the current activities that are being developed in the rulemaking forums. The first thing that we can find is that the European Commission is aware about what platooning means, and is aware about which solution is needed in order to provide a real framework for the deployment of this technology. We have listened today to other speakers speaking about the efficiency, about the security, the safety of the vehicles, about the cleaner vehicles in terms of reduction of CO2, in terms of reduction also of pollutant emissions. The European Commission was aware of about that when they published this general safety regulation back in 2019, but they also state that this technology would not be possible without a suitable regulatory framework that could cover those technologies. In this same regulation, in Regulation 2019-2144, this general safety regulation, they introduced the tool, or they introduced the structure for these new requirements on platooning to be set. As you can see on the screen, this regulation includes a line within the list of requirements which is specific for platooning. And also you can see that from July this year, from July 2022, the intention of the European Commission is to make this regulation, to make this set of requirements mandatory for all those commercial vehicles that are fitted with this platooning functionality. But also, if you look at the screen, you will see that there is something missing. There is an important gap here. And this gap is the number of these regulatory acts. So we have the structure, we know what is to be done, but it has not been done yet. So our work here, our work within the context of this project, of ENSEMBLE project, is to create the contents, to fill this gap. And this is something which is closely aligned with the speech this morning from Mr. Anthony Lagrange from DG GROW. So our intention is to provide a solution, to provide at least a first draft so that we can fill this gap. Before starting with the proposal itself, it's important to understand which is the link between the GCR, this General Safety Regulation, and the European Commission regulations, and the UNECE WP29, which is the World Forum for the Harmonization of Vehicle Regulations. It's important to understand that because those are the main sources that we have been using in order to create this proposal, in order to fill this gap that we have been identifying. If we have a look at the screen, we will see this red dot, which represents this platooning functionality. And we will see that this falls within the competence, this falls within the scope of the activities of the features that the European Union wants to regulate. We have two different possibilities here. And the first one, which is the preferred normally from the European Union, is to directly adopt the regulations that are being developed within the framework of the UNECE. The main problem that we have is that, in this case, we fall under the second possibility, which is that the UNECE does not include platooning within their list of priorities, which means that the European Union needs to develop their own regulatory framework. That being said, let's go with the proposal itself. And what we have done, our intention has been to create the contents to fill that gap that we identified with the requirements for vehicle platooning. And as I introduced before, our main sources of inspiration have been the current framework or the current work being developed at the European Commission level, and also the main principles, the main discussions on the experts, on the expert groups from the UNECE. So if we have a look at the framework from the European Commission, we can see that there is already a draft regulation on automated driving. This is a draft regulation which currently focuses mainly on two use cases, which are the robotaxis and the urban shuttles, so quite different from what we are talking about today, quite different from platooning. But in terms of structure, in terms of the skeleton, we could say, for this proposal regulation that we have been creating, it has been a very important source of inspiration. We didn't want to create something different from what the European Commission is working. We don't want to diverge from their positions. We don't want to diverge from their working style, we could say. So we have used this draft regulation as the skeleton, as this structure, this main structure for our future regulation proposals. On the other hand, we have the work that is being developed at the UNECE level, this WP29, but also WP1 for traffic safety, and the huge list, the wide list of working groups, expert groups, informal working groups. There is a lot of people working currently in developing regulations for automated technologies. Unfortunately, they are not focused in our use case. They are not focused in platooning, in vehicle platooning, but the technical principles, the main approach to the regulation of those automated technologies has also been used for the purposes of our proposal. Of course, the intention of this slide is not to go into detail on the different working groups that we can find within the scope of the UNECE, because we could spend hours and hours explaining that. The main message of this slide is just to say that the contents have been created inspiring ourselves on the huge amount of work, the huge amount of discussions that is being held in this specific forum. That being said, we know which are our sources, we know which methodology or which was our thinking when we created this proposal, and let's have a closer look at how this proposal looks like. Of course, we will not get through the complete proposal, but we will see some of the main principles that we have taken into account. We have split our proposal in two main parts. The first one being the functional and construction safety requirements. And in order to generate those requirements, as I mentioned before, we have taken the inspiration from the work that is being developed at the UNECE level. And if you are familiar with this work, you will see that the main list of topics that we have taken into account or that we have considered as requirements that shall be met by vehicles fitted with this platooning feature is the same list that you can find in the framework document as the safety vision of the UNECE. This list of topics includes the system safety, so how do we define that a vehicle is safe, which conditions shall comply this vehicle in order to be considered to be safe. Also the fail-safe response, we are talking about vehicles which are fitted with a lot of ADAS and connected and automated functionalities, and as we all know, electronics may fail, and in that case of failure, this vehicle needs to be safe enough in order to not be a danger for the other road users. Also, very important, we are talking about a technology which is based in connectivity, and connectivity without cybersecurity makes no sense. So cybersecurity is also in our list of requirements, together with software updates. Software updates that were dealt together with cybersecurity in the expert groups in the United Nations working groups. So we also consider both of them. Together with the HMA, especially in the cases in which we are dealing with automated technologies, it's very important to create this connection, this relationship between the human driver and the machine driver, so that the human driver can be informed about which functionalities are being leaded by the vehicle, or at which moment the vehicle will give back the driving responsibility to the human driver. And finally, the EDR, also very important when we are dealing with automated driving technologies. It's essential to understand, in case of accident, in case of incidents, which have been the causes of this accident, if it has been a human-led accident, if it has been because of a failure in the technology, not only in order to identify who is to blame for that, but also in order to evolve, in order to enhance that technology, and in order to avoid possible recurrence of the same accident or incident. On the other side, I talked about the safety requirements that we took into account, but very important as well, when we are talking about automated technologies, is the way in which we are going to evaluate those technologies. In the past, the regulations defined a quite easy approach for all of us, which was testing vehicles in the proving ground or testing vehicles in the test lab against a very limited set of scenarios and evaluating the results against some limits which were clearly established in the regulation. But if we are moving into the automated driving zone or environment, we see that this is not possible anymore. The huge number of scenarios to be evaluated is not feasible to be dealt with the classical proving ground test. That means that the new assessment and testing methodologies that are being defined in the UNECE, specifically in the VMAT working group, the validation method for automated driving, needs to be taken into account. And this methodology includes three main pillars. The first one being a combination of the assessment of the development methods of the manufacturers, together with some simulation in order to reinforce the information taken from this assessment, together with some track testing, so for certain scenarios that may be critical for safety reasons, it is still essential to test those vehicles in the test track. And finally, accompanying all of that with real-world testing. We are not only evaluating performance of the systems anymore, we are also evaluating the behavior of the system, how the vehicle is interacting with other road users. We have seen it before in previous presentations, and this is something which is also essential for the purposes of the type approval of those vehicles. That being said, I provided a very light overview of our proposal. If you are interested in that, I think it's available in the website, or it will be. And otherwise, you will see it soon published in the framework of the current or the future regulatory framework for the European Commission. So, as conclusions of our work, what we can say is that we were interested in finding the way to go from the idea to the reality. At the beginning of the project, we didn't know how we needed to arrive there. We learned that it was necessary to define some road, to define some way of reaching our goals. But what we have defined in this project is not the final road. We have defined a set of tools that can be used in order to build this road. And we are happy to say also in line with the comments from Mr. Lagrange this morning, that those tools will be made available to the European Commission so that they can continue the work that was created here at ENSEMBLE project in order to create a final regulation. So thank you very much.
Thank you, Carlos. Great work. You paved part of the way to making truck platooning a reality. And I know this has been a lot of work, so this question might be a really nasty one, but what other type of regulation besides vehicle regulation is required in your view?
Okay. Yeah, we have been focusing this presentation and these slides that you have seen in the vehicle type approval regulation. So those are the regulations that are providing the assurance that the vehicles are safe enough to be put into the road. But there are some other areas around the platooning that also need some regulations in order to be efficient enough, in order to be valid from a business perspective as well. And that includes, for example, the user regulations. So it may include the driving hours regulation, how the drivers the number of hours that a driver can drive in a platoon may be modified depending on the circumstances of the platoon, depending on the position of the vehicle. So this is also some work that needs to be performed in the future. Also, very important as well, from the use perspective, from the traffic perspective, how the different national authorities may regulate how those vehicles can be put into the road. So we are demonstrating that those vehicles are safe, but some regulations on the distance between the vehicles, some regulations on which roads can be used by those vehicles still need to be put in place by the traffic authorities in each country. And also some additional regulations on infrastructure. And so it's a very huge environment.
You're not there yet.
Exactly, and there is still a lot of work to be done.
Great, but at least you found a way and you know how to get these kind of things done.
Yeah.
So thank you so much.
Okay, thank you.
That actually brings us to the conclusion of the technical presentation. So we've done impact, we've done future, and now we really need to hear and want to hear from the key stakeholders. And I have 4 gentlemen waiting at the round table for me, which I will be introducing to you in a second, who will do just that, reflect from a key stakeholder perspective. Welcome, gentlemen. I know you've been backstage for a while now, so I hope you had a great time. We could see that at least you were conversing amongst yourselves. So you probably are already familiar with each other, but for the audience, I'll do a quick round the table. And afterwards, I'll ask you to say a little on which stakeholder group you're representing, and also what is the type of experience that you bring to the table, because this is almost a table full of knowledge and experience. So let's make sure everybody knows. On my right side, I have Stefan Dijks from UCAR, trying to do the best. David Storer from Klipa, Steve Phillips from CEDAR, and straight across from me is Carlo Giro from the IRU. We have a wild card who is not at the table. She's standing over there. It's Marieke Hoedemaker. She has been presenting before, and she's the project coordinator for ENSEMBLE. So whenever we have really difficult questions, we'll rely on your knowledge and experience, Marieke. Great that you're here as well. So can I ask you, Stefan, to say briefly something about the stakeholder that you're representing and also the experience that you bring to the table?
Yeah. So, yes, my name is Stefan Dijks. I'm the director of UCAR. UCAR is the research association of the automotive OEMs in Europe. And together with the stakeholders, we worked on a partnership that is called the CCAM partnership. And we will talk about this, or it was already referred to a little bit in the future. And I think the CCAM partnership is as well relevant. So I'm here for UCAR, representing the automotive OEMs as well as the CCAM partnership.
Great. So you're actually 2 people.
Or I have 2 heads as one
well,
person.
That's also strange. David.
Yeah, so my name's David Storer. I'm the Director of Research, Innovation, New Mobility at Klipa. So Klipa is the Association of Automotive Suppliers. We work obviously very closely with the vehicle manufacturers, so with UCAR. But I'm also involved in the CCAM partnership, leading the cluster on vehicle technologies. And yeah, I've been involved in many European projects over the past 30 years. And I was also involved in the beginnings, let's say, of the ENSEMBLE project.
Great. Well, we'll refer back to that in a minute. And I also see this sort of red thread going through this audience all of a sudden, because CCAM. It's like you all have sort of similar functions and are part of similar associations. That's interesting. We'll unravel this a little bit further. Steve, can you share a little bit with us who you're representing? And if you're also part of CCAM.
Yeah, thanks, Karen. Yeah, you're right. There is a red thread emerging. So my name's Steve Phillips, and I'm the Secretary General of CEDA, the Conference of European Directors of Roads. So we represent the road authorities. And yeah, you know, I have to be honest. I mean, I've known these guys for, well, I think David's case probably, at least 20 years. And we have worked together on many, many different topics. And I was also involved in the, not necessarily in the start of the ENSEMBLE project, but the European Truck Platooning Challenge.
In 2016.
I think all of us are members of that group. And well, you mentioned the challenge itself was 2016, but I think it was 2014 with ASEA over a good glass of red wine, I think it was, where we came up with the idea of the challenge. But even then it was building on, you know, a lot of previous work on platooning. But I guess just, you know, why I'm here, we've heard it, you know, road authorities are not vehicle regulators. So, you know, we haven't necessarily got a stake in promoting the technology as such. But I think, like all stakeholders, you know, we want safer roads, we want greener roads, we want more efficient roads. And underlying that, the foundation for that for us is we can't do those top three without preserving the infrastructure.
Makes total sense. Thanks, Steve. Carlo.
Yeah, my name is Carlo Giro, and I work for the IRU. The IRU stands for the International Road Transport Union, and we represent the interest of commercial road transport, not only freight, but also passenger. And why we're here is, first of all, to congratulate the project crossing the finish line, but as Steve mentioned, the IRU was also heavily involved at the beginning in 2016 under the Dutch presidency. And for us, it's we're extremely happy to be here to see as well what the project has accomplished and also discuss the next steps and what has to be done for the future. So I'm looking forward to our discussions and willing to engage further.
Great, thank you. And also for outlining the agenda a bit. So this is literally what we'll be doing. Just looking into achievements, but also looking into the future. But maybe going back to that, well, not entirely to the glass of red wine, but going back to the start of ENSEMBLE. So you all have been involved, but I'm looking at you, Stefan. Why was it so important that something like ENSEMBLE was actually set up?
Yeah, it was in the European Truck Platoon Challenge when we said, okay, we challenged ourselves to demonstrate platooning is possible. But what we did was single brand platoons that all traveled across Europe. The huge challenge was, could we take all the individual brands and then put a platoon together and make the technology of multi-brand platooning possible? And that in itself, it sounds easy, but it's a huge challenge.
Oh, it doesn't sound easy at all. I mean, even just coming to think of the idea, were you not even scared by your own idea?
Well, it was not my idea, of course, but those that had the idea is, of course, they are all very much aware that it's a huge challenge for the manufacturers to share information that is sensitive and competitive information. And when you look at, okay, you have one system with braking and steering, then you have another system with braking and steering, and then at one point in time they need to exchange the information on braking and steering. How can that be made possible? So this huge challenge we facilitated by setting up the ENSEMBLE project and bringing all the stakeholders together and finding a great way how that could be solved. So I'm congratulating the whole project team of ENSEMBLE. It was a huge challenge, but you did it. Congratulations.
Marike is over there taking all the credit. And we'll go into some more detail because I really want to understand how you actually brought this to completion, got them around the table, and also got them to really want to share this, because it's an interesting concept, but then are you willing to? But we'll get to that in a second, because I was also triggered by your 30 years of experience with these type of European projects. What is, if you compare that 30 years and all the other projects you've done to ENSEMBLE, then what was sort of the key benefit or key takeaway from the ENSEMBLE project?
Okay, so ENSEMBLE, in my opinion, is an excellent example of cooperation. You know, we're putting together all the vehicle manufacturers, all the suppliers, many research centers, and it's difficult to do that and to accomplish the result that's been accomplished. But let me also take the opportunity to go back in time. We've been back already to 2016, when there was the trick platooning challenge, and the Dutch government that was very instrumental in putting that forward. But let's go back even further. And in one of the first slides that we were shown today by Marike, it actually goes back to 1990. Now, 1990 might seem like prehistory to many people.
To some.
But, you know, I think it's important also to reflect on the situation we're in 1990. It was the time that the Berlin Wall was being pulled down. The Iron Curtain was falling. And we were looking forward to many years of peace and prosperity in Europe. But importantly, it was a time when it was possible to spend less on military and defense and more on, let's say, technologies and developments that benefit society. As a personal anecdote, I was actually a young research engineer working for the Ministry of Defense in the UK in 1990. I had been training with them for several years. And suddenly, fortunately, there seemed to be no more need to invest in defense. And that's when I changed sector. I actually changed country. I went to Italy and started working in the automotive sector. That's 30 years ago. And what's important also is to understand that over these 30 years, there's been the development of the framework programs, as we call them now. In the past, they were called Bright Europe in that time. But these programs have really been instrumental in bringing together the different stakeholders from different countries, getting to know each other, working together, learning to respect each other. It's been instrumental for peace as well across Europe. And you know, when you look at these different projects, and mention was made, for example, of the Chauffeur project in the 1990s, and the Sartre project, which was after that as well, again looking at platooning. You know, what we're seeing is the development of technologies, but also this understanding of this working together, collaboration, reducing fragmentation. And that's where we are today with ENSEMBLE. And ENSEMBLE is a really excellent example of this, bringing together all the heavy-duty vehicle, the principal heavy-duty vehicle manufacturers in Europe, working together on a common problem. And it's not easy to achieve, but ENSEMBLE has achieved that.
That's wonderful. It feels like we're sort of standing on the shoulders of giants, the way you describe it.
Yeah. I guess
so this is
right.
sort of the end game of, well, not end
Maybe
game,
not
but
the
it's,
end game,
it's
but
the child of.
An important milestone. That's
yeah, thanks for putting that into perspective. And I'm also trying to think about, so what does it mean for this day and age? Yeah, maybe looking at you, Carlo, from your IRU perspective, what does it mean to IRU?
Well, we see, I mean, as David pointed out, a lot has changed throughout, I mean, the decades that we've been through, and the commercial road transport sector is evolving constantly. It's a very dynamic sector in which you have a lot of things coming up. We see now the European Commission focusing on the environment, in particular on the Green Deal, but also making efforts to promote digitalization. And this is where I think that the ENSEMBLE project comes well together in terms of putting digitalization and looking towards as well decarbonization, of course looking into the autonomous function to the future. So looking to this is very exciting for us to, first of all, be exposed to this, as we feel that, well, we know that our industry is extremely important and it has to be put in the right conditions, also through platooning, to compete. And therefore, we can only welcome what ENSEMBLE has done, and we wish, well, our hope is that this will be carried on further and that this will benefit the overall industry. Let's not forget that the commercial road transport sector is a sector that is also composed primarily of small and medium-sized enterprises. So looking at Ensemble, one of our, not asks, but we would like at least truck platooning to consider is the fact that truck platooning should also look into the accessibility element. So in order to make these platoons as flexible as possible so that companies that are not large players also have the opportunity to join them. On top of that, and maybe taking a step back, is to also inform the industry and let them know. And I think Ensemble has done a terrific job in terms of first of all, finishing the project, but also coming out with concrete results. Now, and this is where we could play a role, is to go to the transport companies and inform them about these new technological novelties. I think that user awareness and user acceptance will be key for these technologies to be adopted and to be taken up by the industry. So therefore, I'm very excited to work together, considering the fact that the project will finish, but also looking further and making sure that the key findings are translated in an easily understandable manner by transport companies.
Yeah, I think actually in the European Commission roundtable it was mentioned that we should have these demonstrators in each country, also taking local circumstances into consideration, but also exposing actually the transporters to this new type of transportation.
There's a lot. I mean, there's a lot to be done in that aspect, I think, and that could. I mean, the easier we break it down to the transport companies, the more they will understand, and they will not be reluctant to embrace new technology. We see the same thing, for example, in the environment, on the alternative fuels. We have a hard time convincing transport companies that this is the future, but
until it is the future.
Until it is the future. So we have to do this exercise of really getting on the ground and talking to all stakeholders to make sure that they know what is going on, not only in Brussels, but in other parts of Europe.
So that's the awareness bit. I'm also triggered by the accessibility. So what would make it accessible for the small and medium-sized enterprises?
Well, I guess not restricting the access to the platoon. So kind of developing a system where, now I can't predict the future, but designing a system, an open, transparent system in which stakeholders or transport companies in this case would be able to join a platoon and leave the platoon according to their needs. So forming these platoons on the go, this is something that we've looked into as IRU, and this is something that as well our members are keen to know more about. So the accessibility part in making sure that all players are included and not limited to just a few. As I said, it's a commercial road transport sector. There's competition, so we need to take that in consideration.
Yeah, I think I briefly touched upon that as well in our conversation with Ernst Jan. That by nature it's maybe not the most, how would I say that? I'm not going to say it because that's going to be a statement that's going to haunt me forever. What I will do is build a little on. I mean, this is also the final event, so we can be celebratory and sharing compliments and stuff. But getting all the different stakeholders around the table. I'm just going to Marika and ask her who were the stakeholders that were around the table. I mean, who did you really have to drag in to make this such a success? Can you share, because I don't think we've mentioned it today, all the parties that have been part of this process and this project?
Yeah, the actual project actually, yes. I think I mentioned very quickly in the beginning that we were with 19 partners, but that doesn't say anything because behind these partners are at least 10 times as many individuals working on the project. And to be honest, I did a quick checkup on our internal SharePoint where we exchanged all the information together within the project. There were more than 300 individuals that worked together on this project and that were working hard, that might have had 1 or 2 sleepless nights during the project. And they came from all of those OEMs. They were there working hard, trying to agree with each other, even though sometimes, of course, you don't agree with each other. There were research scientists from the research institutes. We had the automotive suppliers there, also very, very actively involved in thinking about the specifications, because it's also very important for them. And then, of course, there was also Ertico organizing this with the dissemination part. And that's only the people that were in the project. During the project, we've reached out, of course, to all of you out there. But this is just a glimpse here, I guess.
How about your sleepless nights? So what was really causing your nights to be sleepless, if that's even the correct formulation?
Well, yeah, to be honest, I had sleepless nights sometimes as well. Thinking about when we started out, we were around the table, everyone was enthusiastic, but we were not, it was not aligned at the same moment. That really took us a lot of actual, and I have to be very grateful that we could do this in the beginning of the project in face-to-face meetings. We got to learn we got to know each other there. We had dinners together, which helped a lot in trusting each other and saying, okay, this is something we're going to do together. But yeah, sometimes at some point, this is still way out, there is a huge gap between these two. And then in the end, we came there, we closed the gap together, I guess.
Great, the human element, so the secret sauce to the success.
The human element is a big part of the secret in the end.
Yeah, well, maybe we should mention that at the end, that the technology and the regulation and all the good stuff that we saw today actually didn't come about without all these great people.
Yeah.
But we'll get to that maybe in a while. Let's also talk to look into the future, because it's great that we're all interested and that we made a lot of steps, etc. But this is the final event of Ensemble, and we're all very happy. And it's a child of a long process, but we want the child to go to school and grow up and become a truck platoon or something. It's a strange metaphor, but you understand where I'm going. So how about that future? I mean, and what is a logical next step? I'm just going around the table. Who would like to say something on that? David.
I mean, I would like to just develop this concept that Marika has been proposing of a project like an ecosystem. You know, you get all these different partners coming together. Now, let's not forget that normally in everyday life, these partners are competitors. The truck manufacturers are competing against each other. The suppliers are competing against each other. And so, you know, that's what's remarkable about bringing together all these different partners in a project in an ecosystem. And I think it's also very interesting, getting back to what I was saying before, about how the European collaborative R&I system has developed into a complex ecosystem. You have projects, but you also have technology platforms, which were set up a few years ago, and very, very important. AirTrack is the technology platform in our area of road transport research and innovation. And then you have now the partnerships. And we mentioned before about CCAM. CCAM is the partnership on cooperative, connected, automated mobility. That's what it stands for. And this was set up over the last few years, and it's now active. And that, from my perspective, represents the way forward, because it's really going to be the context in which the different stakeholders will come together, are coming together already, defining common priorities, defining even specifications, working together on projects. And that, for me, represents the future. This is where I think some of the learnings that we've had from the outcomes of the ENSEMBLE project will be developed further and be implemented further within this context of connected and automated mobility.
Great. So then I'm also looking at Stefan, because you also, with the two heads, are part of CCAM. So we have had a successful demonstrator. What else would we need to take another step towards truck platooning, and how do you see CCAM playing a role in that?
Yeah. We heard it today. So we've seen that the technology is working. We've seen that the technology is there, but we heard as well that there are pieces missing. So we are, and we heard from the Commission what they are looking into these pieces that are missing.
And you're referring to the regulatory framework.
To what Mr. Lagrange said. And we need to be, of course, aware that still after an important demonstration, we still need to go some steps to be able to implement it. Now I think it is good that the Commission is thinking how to implement platooning and look at how to make the regulatory framework fit to make it useful. but still we need to make that in parallel. We need to be quicker when we look at our actions that we take from research and innovation and how we bring it into reality. And one of the big advantages in the CCAM partnership is that we're actually making quicker interactions between what we do with the users when we make real demonstrations, real interactions, that we work with users, and that we look at how can we feed back information to the regulators and have a quicker implementation loop and accelerate innovation. And I think that is one of the huge improvements of how we're doing in the future the work on connected and automated mobility. So yes, we learned a lot from Ensemble. We still have to do our homeworks to implement it, but we will take the lessons learned in the CCAM partnership. And that is a huge benefit for all of us.
Great, so it feels like there is a safe and caring place for the Ensemble outcomes to land. And you might also tackle sort of the boundaries that are still hindering the business case if you start working on it in CCAM. Steve, what would you like to add?
Well, thanks, Karen. Yeah, I mean, well, I guess first I was reflecting on David's comment because, yeah, bizarrely in 1990, I also turned down a job offer from the Ministry of Defence and started working for the Department of Transport. But the part of the reflection there was, if we look back to the 1990s, you know, when I started, we were in a situation where typically the national governments worked with their own national champions, if you were. That was the way that European research was set up. And what we've seen, as David has said, is over the years, we've seen, you know, firstly, the national champions have become more international, and we've also seen this, you know, much greater cooperation across Europe. And I mention that because, you know, I think it's important, you know, as we start the CCM partnership and, you know, to, you know, open and transparency. Yes, CEDA is a member of the partnership. Actually,
I thought so.
And well, actually, that's deliberate because it is the first partnership that CEDA has joined. I mean, that's very significant. It's the first partnership that we've joined together with the industry because we need to rebuild, if you like, that cooperation that maybe existed back in the 1990s at a national level and try and build that at more of a supranational level. And that's really important, I think, for, you know, for a lot of the projects that Stefan has said. Yes, it's important, and Ensemble will be, I think, when we look back in the future, will be, you know, part of this continuum that we started. It was important. When CEDA, I mean, let's face it, CEDA was not directly involved. You know, we had a big role in the truck platooning challenge because that at the time was about demonstrating cross-border operation. Because that was the big concern at the moment, at the time was, oh, it might work at a national level, it will never work across borders. The challenge was to demonstrate that, but that was mono-brand. Then the next challenge that the automotive industry comes up, oh yeah, but will it work multi-brand? Okay, CEDA, there we kind of sit back and say, well, okay, you know, go away and work on this because this is not how it works, this is your work, prove that it works. That's also an important part of the process, you know, because there is still a lot of doubt, hesitancy, you know, will it work from all of these different reasons? And people sit back and they're waiting for that bit in technology to be developed. And what Ensemble has done is it's shown that, I won't use the word platooning, and I'll use it deliberately, is if we look at, you know, connected and automated position keeping, because I think as we move forward, that's the kind of technology we've seen, because that's the technology which we will see will protect the infrastructure, bring about road safety improvements, you know, bring about savings in fuel, and then, of course, you know, the efficiency. So all of those things, if we can put those together and move it forward, I think, you know, we have the potential, we saw it earlier, we have the potential for this to deliver on safety, environment, and efficiency. If we don't, then, you know, we've lost a big trick and we should kick ourselves for it.
Steve, I mean, I think we should just wrap up and go home. This is like the perfect end of the day. No, Stefan has a better ending.
I fully agree with Steve. But what we should not forget that the times or the development times is accelerating. So the digitalization is really accelerating how we look at things, and what we looked in 10 years ago or 20 years ago, and now when I look back what we said 5 years ago and what we know now. So things are developing, and these accelerated development times we need to consider as well in the way that we act and interact with the stakeholders, as I said, with the regulators, with all. We need to take this speed into the way we work in the partnership, in the projects, and how we interact. I think that would be the little piece that was missing in Steve's summary that I wanted to add.
That is wonderful. So I hear an ecosystem we needed to be able to be agile and keep up with technological developments, and at some point we also need to make sure that the end users understand.
Of course.
Yeah, so if you're listening to all this, you were talking about awareness, accessibility, and things are speeding up, or the ecosystem is there, and we move forward. We have mono-brand and multi-brand, and then I always want to ask, what is the next one? So after multi-brand, what's yeah, you don't know, we still, okay, it's not a test. But
I would
if
say
you
multi-stakeholder.
Oh, wonderful.
And
Yeah.
I say that deliberately, as I say, a lot of the safety benefits we will see from not only the vehicle to vehicle that we've seen demonstrated, but the vehicle to infrastructure and the vehicle to. So you're right. It is the ecosystem that we're building.
It's David, who brought it up. But if you listen to all that, Carlo, what are you thinking with your stakeholders in the back of your mind?
I can only echo what has been said. I mean, from our perspective, we do see truck platooning as a stepping stone towards full automation. So we see the learnings from Ensemble to help us get where we want to get, also in the framework of the partnership. So I can only echo what has been said, and as Steve said, Ensemble, we will look back to Ensemble, we will think to ourselves that Ensemble really kickstarted the whole process and was a means to get to where we want to get to. So I can only echo what has been said previously. Yeah.
Thanks, Carlo. Well, I think...
I
was about to say there's nothing more to add, but then David
I want to say one last
is
thing.
inspired. Please.
It's the name Ensemble. I wish I'd come up with the name Ensemble, but I can't take the credit for it. It was somebody else's brainchild. But it's a really good name because obviously it means together, but it also, I think, gives this idea of professionals, maybe professional musicians, working together in a group. But in order to have the balance and harmony that you expect, particularly if the group is big, you need a conductor. You need somebody to orchestrate it. And, I have to say that Marika did a very good job as coordinator, and it's a really difficult challenge, and she did it very, very well. So Marika and the team at TNO, and obviously the team at TNO was supported also by Etico and also ourselves. But really, I think we have to acknowledge the fact that it was very well conducted, and that's down to Marika.
I think that's a wonderful statement, David, to make at the end of this round table, and almost also at the end of today. I'm looking there. Yay, perfect. Because first of all, thank you all for joining this panel and for sharing your stories, because we know now that it goes way back. The success that we're celebrating today. For everybody back home, what we'll be looking at right now is a short movie of all the highlights and the achievements of the Ensemble project before we go into the final closing session of today. Enjoy.
Ensemble. Platooning together. Today there are some 6.2 million trucks in circulation throughout the EU. They carry 73.1% of all freight transported over land in the European Union. But what impact do we see on the roads? How does it affect the journeys of other road users? In Ensemble, designing fail-safe and fault-tolerant mechanisms is a priority to ensure safe interaction both within the platoon and with other road users using secure wireless communication. The Vehicle-to-Smart Infrastructure Communication, or V2X technology, assists in the quick deployment of the platoon on the road and guarantees coordinated speed and rapid reactions in potentially dangerous situations for the platoon. Road authorities can benefit from platooning as the interaction and uptake of the platooning functionality can also accelerate the digitisation of vehicles and logistics. The communication protocol developed in ENSEMBLE enables interaction between trucks of different manufacturers. Truck platooning increases road capacity when the volume of trucks in the total traffic is high, at around 20%. Traffic flow is also found to benefit more when truck platoons operate in traffic situations where trucks are predominant, for example in industry or port areas. To avoid negative impacts, such as congestion and bottlenecks, for instance in road segments with many highway entries, hub-to-hub platooning and platooning at night can be good solutions. The European Commission, in the framework of Horizon Europe programme, has proposed a new public-private partnership to support the efficient development and deployment of connected and cooperative automated mobility, CCAM. The ambition of this partnership is to accelerate innovation in mobility in the EU and develop a shared innovation agenda. ENSEMBLE's progress on platooning is another step farther in the mission to deliver innovative and sustainable mobility solutions for all. In 2016, the European Truck Platooning Challenge, ETPC, showed how the multidisciplinary teamwork between stakeholders was essential to realise this new form of truck platooning mobility.
In 2016, the truck brands, they already showed that they had the technology available for this platooning, and they did it in a mono-brand way. So brand by brand, they showcased this platooning technology. And this was done in the so-called ETPC event, European Truck Platooning Challenge event, in the Netherlands in 2016. So this was very successful, and it took a lot of attraction. And then afterwards they were wondering, what are now the next steps to be taken? So, one, make sure that there is a European standard that enables truck platooning on the road by combining all the brands together in a multi-brand approach. Two, ensure compliance with the existing road regulations, of course, so to ensure a quick adaptation on the road. So, three, they had the idea that whenever the trucks meet each other on the road, that they could immediately form a platoon, and on the fly, in fact, when they meet each other. And we call it ad hoc platooning. And the way we did it is we created a matching service behind it, so that whenever the truck meets each other, that they could platoon and that they could benefit from it.
Let us take you on the ENSEMBLE journey. Truck platooning is the linking of two or more trucks in a convoy, using connectivity technology and automated driving support systems.
As the coordinator, I'm very proud that after almost 4 years of intense cooperation between truck manufacturers, suppliers and research institutes, we came to a common solution for multi-brand truck platooning, ready for further standardization. This means a step forward towards deployment of platooning on the roads, which in turn can bring improved road safety, reduced fuel consumption and efficiency gains in logistics. The mission of ENSEMBLE was to pave the way for multi-brand platooning. Now the project has finished, we can see the success of the project because ENSEMBLE has significantly improved the understanding of platooning and accelerated the development of the required technologies by aligning them for all European truck brands. The ENSEMBLE developments are an important, necessary and intermediate step towards a future autonomous platooning function that enables smaller following distances in a safe manner. As specifically autonomous platooning is expected to bring more positive impacts and a good business case, accelerating these developments is of key importance, while at the same time considering vehicle technology, infrastructure, road operations, logistics, and of course, the professional drivers as the important end users.
After 3.5 years, months of testing and many hours of alignment, ENSEMBLE partners succeeded in demonstrating a 3-brand and 7-brand truck platooning.
Thanks to the excellent collaboration between all the partners in ENSEMBLE, significant technology advancements have been possible, enabling trucks of different brands to communicate with each other for the formation of a platoon. The contribution of the suppliers involved has been fundamental for the creation of a communication protocol, leading to the implementation of the platooning functionalities in the different trucks and paving the way for smarter, safer and more efficient road transportation in future.
Platooning also affects the road infrastructure. The ENSEMBLE study has shown that truck platooning will influence the wear of roads and bridges. The potential benefit of platooning is that the road authorities are given the possibility to influence the parameters according to which the trucks are driving on their pavements. In tunnels, the potential benefit of platooning is that it gives the possibility to decrease the current very large distances between trucks. This will lead to a higher flow of trucks through the tunnel and therefore to more efficient logistics around the tunnel.
In the spirit of ENSEMBLE, all partners have played their part.
How did we achieve these important results? This was only possible when we had all the stakeholders involved and when they all cooperated. And that's, in fact, we were looking at the most important, like the road authorities, the truck manufacturers, the suppliers and the logistics umbrella organizations.
ENSEMBLE's achievements must be valued as an important intermediate step towards a future autonomous platooning function. Accelerating these developments is of key importance for realising vast business impacts. ENSEMBLE, platooning together.
It's interesting to see you actually on the movie, and now also to sit down with you here in real life. This is the end of what has been a very intense and I think also exciting day. We can almost hear the rest of the team popping the champagne behind the corner. But it feels appropriate to just sit down here, sort of at the fireside, contemplating over these last 4 years, because these have been the best 4 years of your life that you dedicated to truck platooning. So what for you is the key takeaway from those 4 years?
Yes, well, I think we heard already a lot of nice takeaways during the day and also in the last movie. So I'm not going to repeat all of that. I think when I have to pick one or two, I think that was what is very important, that we laid the foundation together for further autonomous driving, and that it's actually the beginning of new exciting research and development that we need to do together again with the foundation of this autonomous platooning specifications that we have. And that's not only on the technical side. We've also seen and emphasized again how important it is that we put this into perspective, that we look at the regulations, that we look at how can this be done safely, and that we look at the effects for the drivers, the road users, the manufacturers, for all the stakeholders there. But I think that's one of the main things that I want to end with.
That is great. That you end the 4 years of researching and studying with the excitement of what is about to come. I mean, that feels like good news,
it's
right?
more to come. I think that feels better, I think, and it feels good instead of saying, okay, we've done everything, now we can go home.
Tick the box, this is it.
We can't go home. We need to keep moving with this.
Yeah. Nice,
So,
especially with regards to the truck platooning. We have to keep
Yeah, we
moving. And also feels like we're ending on a high. And I think we just discussed in the panel that you were also part of, who's going to adopt a child? So if you're talking about the excitement that is still there, that is just about to come, then to whom or to what do you want to pass the baton? You don't want to drop it on the floor. You want to make sure that somebody else keeps on running with it.
Yes, true. And that is actually, I think it's important, and I think that's why we're so happy that the CCAM partnership, already discussed in the panel quite a lot, is there, because it's the partnership, but it's also still, of course, the European Commission that is there to help us to steer the direction in which we go together with the CCAM partnership stakeholders in there. So I think I'll bring it to them, and hopefully it comes back to me at some point. So I'm so I can
In what sense?
mingle
How do you
in
mean that they gonna take it further and then give it back to you again?
and then say, hey, we have this great project again.
This is an open application.
Yeah.
Great. No.
So, but yeah. So, and actually, we've heard in the panel this morning, Mr. Lagrange saying that that it is taken up. He already said and announced that the platooning protocol that we developed will be part of the regulation. It will be there when you want to have a communication. It needs to be done with the Ensemble V2V protocol.
Yeah, I was about to mention that because you said I'm going to bring it to him, but it also sounded like he was accepting it with open arms.
He was already accepting it and saying, "Okay, we take this up from here." Yeah. So it's already given to someone.
It's moving
there.
already.
Moving. Yeah.
Hey, and then if you dream big, because you've been into the nuts and bolts of truck platooning, what do you envision, or what do you hope the future will hold?
Well, the future, I hope, is, I think this that we will move on with this in the way we did with Ensemble. That maybe Ensemble didn't even have all the stakeholders in there. So the thinking about what is needed and do this together with stakeholders, I think that is what we need for the future. And we need more stakeholders, like the road users, like the drivers. We should ask them what they want when they want driving in more autonomous vehicles. Can be very exciting, but we have to take them. We can't decide for them. So I guess that's the future will hold more autonomous driving in whatever way. With this building stone, that we can always say, looking backwards, when we are 20 years later, remember in 2020,
that was the day.
That we're still using the basics of what we laid here there.
I think it was also echoed by Carlo just now at the panel.
Yeah.
So that's a wonderful picture for the future, I think. And maybe to close everything off, because I just asked you the stakeholder question, and you began to sort of do the mathematics of how many people were involved, and probably most of them are watching now, are on the other side of the screen. So, is there anything you'd like to say? To them?
That's the only thing I would like to round off and have the last word. Is that the only thing I can do is thank all of you who contributed to this project. So there, as I already said, there were at least 200 people, and I guess most of you I've met in person at some point during the project. So I'm very happy that you were there and that you contributed to the project. You are really a great team to do this together.
Nothing to add to that. Thank you, Marika. And thank you for everybody who has been watching us throughout the entire day in this live stream. It's been an exciting day. It's been an amazing final event of the Ensemble project. Thank you for watching. If you want more information, please go to the website and you'll find parts of the streaming as well. Thank you.